Alrighty. Just fade it nice and slow, right? You have to stop the music. Today, friends. I am on a roll. Let me go back here real quick. Alright. We'll retry this. We'll try again. One of these days we'll do it right. Okay. I think we got it. Just waiting on the projector now. So this is what I get. Trying to make it to the library before they close. No, you can go away. All right. Let's see. Come on. Probably should plug in my computer too. I'm gonna spill the coffee right on my laptop. That'll be perfect. This is why we don't have food and drink in this room, right? All right. One of these days. All right, I think we got it now. Back to our schedule. So we're taking a look at Project 1, going over the solution to Project 1, and then Part 2 of Objects and Classes. We don't actually hit most of these sections all that deep, because you're going to come back to it again later. So shouldn't be too bad today, and then we got to talk about what Project 2 is as well. So we can get started on Project 2. So, all right, let's talk about Project 1. Is that a question? Oh, no, not question. Oh, okay. This one's us, right? Yep. And so my dad's dealing with that. Yeah, I usually parking stops taken, so I don't know. A bunch of people handicapped without stickers. You're not supposed to do that. This is my thing. You know, if I parked there, I'd get a ticket. That's my luck. Yeah.
It wouldn't let me turn my project.
Just email it to me for now, then, okay?
Oh, okay, just email it.
Yeah, then we've got time stamps and everything. Thank you. All right. Our terrible text-based adventure game. Game is a stretch here, right? This is not meant to actually be an interesting game at all. This is game-like, is about as best as we're going to get here. So we'll call this Project 1. And there's going to be a lot of different ways you folks might have gone about this, which is cool. Because, right, there's an art to programming and there's a science to it. The art is how we design it, how we lay it out, how we break it up into these different pieces here. And once we start getting into methods, you can write them any way you want. You can have different method names, you can have different content, they can do different things, they can return values, they can just print things. We got so many different choices here. Totally up to us on how we want to do it. So I like going over a solution. Just because I did it one way does not mean your way is wrong. Right? Just keep that in mind, right? As long as it works, right? So that's why we have our rubric here. When I score stuff, I'll get to it. I'm hoping to get caught up over break now that I'm finally feeling better. So if you have a method for getting valid user input, great, you get your points here. If you got 4 different directional command methods, you get your points here. You got 4 different action command methods, you get your points here. If one of those action commands wounds the player and they can't do anything but sleep, you get your points here. If you're tracking how many turns they spent and they end the game when they enter your secret escape board, you get your points here. Okay? That's how it works. So as long as these are getting accomplished, we're fantastic. You'll get the points. So lots of different methods here. So what I like to do when I think about things is I'm going to go through and put a bunch of methods down that are empty. Kind of like we did with rock, paper, scissors. We said, hey, here's the 3 steps we need. I need the player's throw, I need the computer's throw, and I need to figure out, did they win, lose, or draw? And then we left them blank, and then we came back and sort of filled them in. So we're going to kind of take that same approach with the game here. And again, game quotes. I feel terrible calling it a game, but it's much more interesting than some other nonsense you could do, I'd imagine. I don't know. I let my kids try it, and they're like, Dad, this is boring. I'm like, I know, but it's cool. There's text on the screen. They're like, where's all the pictures? So it can't compete with Minecraft, which is like a decade old, right? And still popular, right? I don't know. It's fun, and like the redstone stuff is really cool. I'm trying to teach my kids circuits and circuit logic, and you build circuits with redstone in Minecraft, and like they feel like they're playing a game, but you're teaching them circuit logic, and like this is cool. I think it's cool. I like building circuits. I don't want to build a whole computer like other people did. They built Minecraft in Minecraft with redstone, and it was nuts. Like how much time they put into this thing. It's a really cool experiment, though, for sure. So what Minecraft is Turing complete. Right, so you can make a whole computer out of it, which is fun. Anyway, so methods and methods and methods and methods. So we need to do a loop, right? And we're going to track some turns. So we have an int for turn count, right? Starts at 0. That's just easy. There's no real method for counting here. We have some turn. You guys got to tell me here. I got to push the right button. No one can see my screen. Oh, yeah. Everyone's like looking around. Where is it? Okay. Yeah, there we go. All right, so turn count. Great. And then we need some sort of command, maybe? So I'm going to start it off as blank here, and then I'm going to run my loop. Again, I hate do loops, so I don't use them. So I'm going to do a while loop. So I'm going to start this as something that I know will make the loop run to force it to run at least once. And then we'll be good to go. So then I can say while my command equals ignore case. What do we want the secret escape word to be?
Escape.
Escape, sure, it can be escape. So, and I want not that. So as long as it's not escape, I want this loop to run. Blank is not escape, the loop will run. Right? So now we need to get their user's command. So my command can equal a get valid command. Cool. I don't have this method yet. That's okay. We'll come back to it. But I will run a method called get valid command, and I'll have command be that. Right? And then I'm just going to put a big list in here. Right? I can say, hey, if the command equals ignore case, what do we want to do first? How about north first, right? We'll do go north. If they entered go north, then we'll run the go north method. Cool. If it wasn't north, how about else if, and I'm just going to copy and paste this. If it was go east, we can run go east. Have it in better. There we go. Oh, too many parentheses? Is that why? No, not enough parentheses. Oh, goodness. There we go. They didn't match here, and I was getting that little red line. Sometimes the red lines are helpful, right? I think it was going to tell me, no, parentheses expected. Look at that. That's a helpful hint. Thank you, IntelliJ. That's useful. Go east. Sure. Else if, go south, go west, This is go south. This is go west. And then we need 4 actions. What kind of actions do you folks want to have available in our fantastic, fun game here? What commands should we allow? Actions. Things that you can do. Walk? Sure, walk. Okay. But we'll call walk. Walk. I can't spell walk. Okay, fight? Sure. Fight. We'll do fight. Cool. What else can we do? We can walk, we can fight. Jump. Sure, we can jump. And then we'll call a method called jump. And then I think one more, right? Rounds out our 8 of them.
Flip.
I'm sorry? Flip. Sure, we can do flip. Why not? Okay. Cool. That's it. So we've got get a valid command. Great. We've got direction commands, methods. We've got action methods. Great. We haven't done the wounding thing yet. We'll get back to that. And then our turn count and ends when they enter the secret escape word. So if it's a valid command, it's going to count as a turn, right? So I can take my turn count ++, add 1 to it. When this loop is done, we can tell them, thanks for playing our terrible game. It took you, and then what we throw in here, turn count. Bump this down a line here. Turns to escape. Sure. Escape. There we go. Okay. So I think we've got that. So we're counting turns. We got our escape word. Again, we'll come back to this part here. That's okay. We got a couple ways we can look at this. Now we actually have to write the methods. So sure. So the little light bulb here is actually kind of helpful. You can make a method with this button, which is nice, and it makes a method. Public static string get valid command. Writes it for me. I don't like typing things I don't have to. So I'm a fan of these. And we can do with all of these. Go north, click my light bulb, make a method called go north. Sure, now I have a go north. We'll do it for all of these. The alt enters the shortcut for that. If you don't want to wait for the little light bulb to pop up, do alt enter. There we go. South, bless you. I mean, all you have to do is hover over the light bulb. No, I love shortcuts, so. Great method walk. There we go. So I asked for them to be separate. I think someone came up with the realizing they could just pass in something and get a different value for each one. That's cool too. The idea was they're separate. I'll show you how we can combine them after, because that's a sane approach and it makes a lot of sense. Like, you don't have to do all this extra work here. Come on, alt enter. Alt enter. There we go. And flip. Come on, and flip. There we go. Okay, so we got a bunch of methods. Now all the red lines went away. They don't do anything yet, but the red lines went away because the method exists. So for get valid command, this one has the red line though, because we haven't returned a value yet. All of our other methods are void. They're not expecting anything back, so they're fine without a return. But for get valid command, we need to ask the user to enter a value. So we'll set up scanner, call the keyboard equals a new scanner, given system in, oops, dot in, great, and then we'll ask them. So what do you want to do? Right, and then we'll get a command. So string for command, sure, is going to be keyboard.nextLine, or .nextLine. And as long as this is invalid, we can keep on telling him something. So I can say, while, now this is going to get long and ugly, and that's okay, because any of these here are valid, and the word escape should be valid, because I have to be able to get that back at some point. I have to be able to get the word escape back from them. Sure. So we have a big list here. So while my command dot equals ignore case, and I'm going to list them all out here. So escape is valid. So I'm going to say, well, it's not this one, right? And it's not the next one, 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 and it's not the next one. On and on and on. So we got north, south, east, west, 1 action, 2 actions, 3 actions, 4 actions. Right? So go north is valid. North. There we go. Go south, or go east. Go south. Go west. And then what do we have? We had walk. We had fight. We had jump, and we had flip, right? So as long as it's not this, and it's not this, and it's not this, and it's not this, and it's not this, because we're anding them all together, as soon as one of them becomes false, the whole thing is false, the loop doesn't run, right? So this only runs if it is invalid. So we can tell them, hey, That's not a valid command. And we should display that little help menu and tell them what they can do. You can pick, and then we'll just tell them here, right? This is go north, go east, south, go west, walk, bite, jump, flip, or flip. Right, and that's a little long, so we'll just bump that down here, and that's probably pretty good. And we'll ask them again, right? We need to update command, otherwise we're gonna have an infinite loop here. So we'll get a prompt here again. And maybe we'll just do both, right? Why not both? What do you want to do? Now, Java gets upset and says, hey, you've already defined this command variable here. You don't need to tell Java it's a string again. We're just giving it a new value. So we'll say command, assign it a new value here. We'll give it a new value. We'll go back to the loop. Eventually we'll run. When we're done, we can return the command. It is a valid command because you can't get out of this loop unless you give me something that's valid. Right? You can prompt and prompt and prompt and prompt and prompt over and over and over. Yeah.
I guess, did you explain again why you write the command at the bottom again?
So I want to update command here.
Yeah.
Because I'm going to ask them to enter it again. So if the loop runs, we tell them you can't do that. Here's what you can do. Enter something. Try again.
And then when you hit a valid command for the command keyboard next on, and then it'll stop it.
Yep. So as soon as one of these becomes false, and we're saying not this. So if it does equal escape, this will be true, and you say not true becomes false, and you and everything together. The whole thing is false. The while loop stops. Doesn't run again, and then we can give that valid command back.
Okay. So once they enter a valid input, then it will
Yep.
Okay.
Yep. So this is our validation loop, and there's better ways to do this. We just haven't gotten them yet because we haven't talked about arrays and lists. I promise it's not always like this. So this is a little ugly, but it's not too bad. A little bit of copy paste, and we'll be okay. Now you probably ran into issues with typos. If you type like I do and you have typos, it's very likely when you typed go north here that it might not match your go north up here. So you got to be a little careful. There's things we could do instead. We could declare variables of a value of go north, and we could use that variable. That's a nice, smart thing to do, right? It's a little silly at this point because we only use it twice, but it's safe. So I can say, hey, I want a string called capital S string for go north equals go north, and then you can use this variable here everywhere you're doing it, which is only 2 places, but that's okay. This is the better way to go about it here. But now it's like, oh, I don't know what this is, right? Because it doesn't exist down in this method. So if you think back to classes, you can make things at a class level. So you can have a class level variable, have a string, static string go north equals go north, and then you don't define it here. So this is, you probably didn't get to this, and that's okay, but that's an option here. This is just an option to avoid using strings everywhere and having typos. Is that a question?
Bottom when you said hold on one, can you put the turn
So turn count doesn't exist in that method. It only exists inside of main. So if you wanted to make it a static variable you could access everywhere, that's an option. But right now, turn count only, so like when you declare a variable, it only exists inside those curly braces. So outside of main, it doesn't exist. There's no access to it. So this is a nice option, and this is probably the right thing to do. It's kind of, at this point, changing it's going to be a little tedious, so I'll show it to you once and kind of go flip them all. It's nice, but this will help you avoid typos, right? So even if you typo once, sure, you're at least using that exact same typo both places. So the commands should work for you. And then we're just going to be really cheesy here. These don't have to be anything interesting. We can just print, you went north. If you had an interesting story, much better. Good for you. You're a more creative person than I am here. Story writing is not my talent at all. So I'm just going to spit back out. You did silly things, right? West. Okay. You went for a walk. You went, or you fought. You fight with a troll. There's a troll in the dungeon or something, right? You jump up and down, and you try and flip. Now, one of these needs to hurt us, right? Eventually, we'll come back to that. Probably flip, because last time I tried to flip, I almost hurt myself. I used to be able to do more flips, but that's okay. Not something. If you don't practice it, it gets harder. All right, so let's give it a try. So we're going to see if it runs now. Again, not fully complete, but we want to try it and see what we get here. So let's give it a run. All right, so what do we want to do? It's not a valid command. I can pick from not valid, not valid. All right, let's give it a valid command. How about go north? You went north. Go north. You went north. Go north. You went north. Go north. Right, as many times as we want. Sure. How about escape? Thanks for playing. Took 5 turns to escape. So none of these invalid ones should have counted, right? But we went north once, twice, 3 times, 4 times. Oh, it was counting escape. Uh-oh. Did it count escape? Maybe it did. I guess our first turn probably counted. So maybe we're off by 1. Yeah, so when we get the valid command, we entered escape, we added this. So, all right, well, when we're done then, if we're off by 1, we can just take our turn count down by 1. That's a quick fix, right? And this is to avoid counting escape, right? So now it should give us the right count, right? We're going to try it and see. Hey, we had a problem. And if you counted escape, that's okay. I'm not particularly concerned. If you did or not, it's okay. But probably shouldn't count as a turn. Or maybe it counts as a turn, right? We had to escape the dungeon. I don't know. Up to you. Either way is okay. All right. So now for getting wounded, if one of these things needs to wound us, we've got some choices. The easy way to do it, and I think most people took this approach, is you come to flip here and you say you try and flip and hurt yourself. You need to sleep it off. And then we set up another scanner in here. Scan our keyboard. With a new scanner. Give in system in. And we say, what do you want to do? That's probably that same prompt, right? What do you want to do? Where's our get valid command? What do we say? Yeah, what do you want to do? Right here. So what do you want to do? Sure. And then we're going to say set up a command again. So string for command is empty. So loop runs at least once, right? And then we'll get the, oh no, I'm sorry, this would run inside the loop here, right? So we'll do this inside the loop. And while command dot equals ignore case sleep, well, it's not sleep, right? We want to keep on running here. Ask him what do you want to do? And then we'll update command. Keyboard dot next line. Next line. If it's not sleep, maybe the prompt is wrong here. You need to sleep it off.
Yeah.
Okay, so you're hurt. You need to sleep it off. We'll tell them that. You need to sleep it off. And maybe they'll enter the word sleep. So some sort of prompt. Again, it doesn't need to be interesting. That's okay. It could be better in the game, but that's okay. So this will keep them from doing anything other than entering sleep. And then we're done. So let's try that. So if I flip, then I should get stuck in you have to sleep it off. When we flip, hurt yourself, you have to sleep it off. You need, oh, okay, the prompt is ugly now. Now we're doing it twice. That's okay. Hurt yourself. You need to sleep it off. All right, so then we enter something other, go north, yada, yada, yada. Nothing counts here. So let's sleep. Then we get back to what do you want to do? I mean, we can even give a message, right? We could say, you slept and feel all better. Which I tell you is not always the case when you get older. Sometimes if you sleep the wrong way, it's even worse. Like you finally got 8 hours of sleep and your body's like, you did it wrong. So, I'm not salty about getting old. It's okay. Attack and defend. Yeah, a bunch of if else's input response. Yeah, that would work, ancient bags. All right. So, do we have a method for getting valid input? Check. Do we have 4 directional command methods? Yep. North, south, east, west. We have 4 action commands. I can walk, I can jump, I can flip, and fight. Sure. Do one of the action commands wound us and doesn't allow us to do anything but sleep? Check. We just did that one. Did we track how many turns we spent? Ends when we enter the secret word? Check. Got our points here. Right. So when we did our self-assessment, we looked at those and said, yep, check, 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 check. 3 points each. We're good to go. We got our 15 points. Feel pretty good about it. Commit to GitHub. Turn in the URL. Right. So I'll get this committed here. 1500. Right. We picked the right class. This is project 1. So now the goal of methods, right? We didn't reduce any redundant code here. We could do better, right? We could do something else. So instead of having all these different methods that basically do the same thing, they just spit out something different, we could turn into one method. I mentioned there's a couple different ways of going about it here. So we can do that. We can have a private static Now, we can either have it do the printing or we can give us back a string. So I want to show you both methods here. So it's okay if you just print in these, but in this case, I'm going to return a string for, this is what, get action or get command result or something, and we have to give it a string for command. So if you tell this method what the command is, we'll give you back the right thing. So instead of doing all of this here, or if it's north, if it's east, if it's whatever here, the only one we want specifically is flip, because that needs to do the wounding thing. So the flip is going to be a little separate here, but everything else we're just going to put inside of here. And then instead of calling another method, again, we could here, we're just going to return, you go north. So we can return the value here. And so then in our main method, instead of doing all of that, so if it's flip, do the flip thing. Else, we're going to get the command result, given the command. Because this is going to return a string, we're not printing anything. So we need to print here specifically in main. So I put all of this in a system out print line. Say, hey, whatever I get back from this get command result, print to the screen. Just a different option, right? Some people did prints right in here in main. Some people did the prints in their methods. Both will work. You just, if you're returning something, you have to do something with it. If you're just printing, you just print, and it works. So all of these can then just say return, you go east. Right? So if we return that string, we can print it when we're done. Return, you go south. Return, you go west. Return, you go for a walk. Return, you fight a troll. Fighting the internet trolls is a never-ending battle. I think the only way to win is to not fight the trolls. I think that's what a wise person told me. Don't feed the troll.
Instead of saying fight a troll, it should be fight Twitter users.
Twitter trolls. No, so you fight the Twitter troll. So there's, depending on how you curate your feed, you can get some decent content. There's actually a pretty lively tech community on Twitter, which is entertaining to follow. I mean, everyone wants you to click their thread and like then open things up because that's how they make their money. But you know, having to click something and open up a thread is not the worst part of the deal here. We'll return you jump. I already committed that, right? Okay, good. So this will be a commit to show the other version. So we'll have the first version committed, and this will be the other version as well. So you can go back and look at that history if you want later. You jump. Sure. Now, this one's upset with me, though, because not every option is going to return something, right? If it's not one of these commands, Java doesn't know that I know it's going to be one of these valid commands. So you have to have this last else of something here with, I don't know, what do? We can probably just return an empty string, and it should be fine because I know I'm only going to get one of these valid ones. That's okay. Or you could put something else in here, like I don't know what that command is, or we got some options for how we want to do that, but I think this is okay. Now, at this point, we don't need to use any of these methods, right? They all get to go away because we don't need them. So other than flip, because flip was special, this is the one that wounds us and has additional things. We can't just return and print a result here, right? Other stuff has to happen. It's an option. So we can do it this way. Right? Here's the special one, and then here's everything else. We just print it out. So this should work just the same for us here. Let's double check. I think these are good. And I think we can just get rid of all of these other methods. Fight, jump, west, south, east, north. Yep. So those all go away. Sometimes it gets silly, like it says one usage, but there's nothing here. It just needs a minute to catch up. So if you did this approach, I'm okay. You don't need the 4 different methods. Like I'll get you the points here because it's essentially doing the same thing. Your question?
Yeah, I'm so confused where the top of the private static string.
This one?
Yeah, why did you in the parentheses need to write the string commission? Why?
So you have to give this method the string that it's going to look at. So this method's job is not to ask for input. So if I need to do different things based on a string, I'm going to give that as an argument. So back up here, we'll get the valid command from the user. Right here, we'll get the valid command, and then I can give that command to my get command result method.
Gotcha.
So that way it doesn't have to do the prompting. We say, I already got this from the user. Here you go, do something with it. Here's the value.
Okay.
So we're just passing that as a argument. So let's give it a try. Let's make sure it works. So stop and run. So what do you want to do? So we want to jump. We jump. Go north. We go north. Do we flip? Sweep. Escape. All right, 3 turns to escape. We escaped. So it still seems functional here with a different approach. This is, kind of as a single method. So we commit this. This is with single method returning values. And then the last approach that I think is kind of fun. So instead of saying, hey, flip is going to hurt you, and then something's going to happen, and it's all going to happen inside of here, if we want to be able to do something interesting with that wound command, and maybe it needs to apply more places, or we can do some other sorts of values, we can have a variable here. Again, probably a class level variable, so it'd be the static variable. We didn't really get into that until the classes chapter, so don't worry too much about it. But I can have this Boolean for wounded. Wounded. We'll say false. So you start off not wounded here. And then what can happen in flip, you try and flip and hurt yourself, then all flip needs to do is say, hey, wounded is true. We're going to set this wounded status to true here. So we're going to move this around a little bit here. So we'll say, so we can add flip back in here. So else if my command equals ignore case flip. Flip then can say wounded is true, you've hurt yourself, and then we'll return you flip and hurt yourself. Or you try and flip and hurt yourself, you need to sleep it off.
Yeah.
And then, that last else, right, will return true. Or just return an empty string. So we've got something here. Oops, that's a semicolon. So by setting wounded to true here, we're going to say, hey, this value now will be set to true, and we can look for this value other places. So if sleep is not separate here, this is just, hey, we're going to get our command here. Right? None of that needs to happen now because flip's already included. As long as they haven't entered escape, let's do something. Great. Sure. So in our get valid command now, we can look and see, hey, if they're wounded, don't let them do these things. So in our get valid command, one thing that we need to check for is if they're wounded or not, to see if this is a valid command. So if it's not one of these things, right, then it's not valid. Or if they're wounded. Right, so all of this then we can group together and say, hey, this would make it invalid. Or if wounded. Now, wounded is a Boolean. You don't need to say wounded equals true. Right? You can say, hey, wounded is true, but that's redundant. It already is true. Saying, does true equal true? We give you back true is just as easy as saying, here's my wounded status. So if wounded is true, we're going to put them into this loop here, right? Unless they enter the word sleep. So if they're wounded, they have to sleep. So we can say, hey, if they're wounded, and my command equals ignore case. So this is like my last little check here. If it's not sleep. So if they're wounded and they didn't enter sleep, their command is invalid. Right? I think we're missing some extra parentheses now. Let's see. Here, there we go. So if you didn't enter escape, or go north, or go east, or go south, or go west, or walk, fight, jump, or flip, it's invalid. Or if you're wounded and you didn't say sleep, it's invalid. Those are no good. Now, but sleep is a valid command. Right? So sleep needs to go on our list of this one is valid. It's okay if you enter sleep. So sleep will be valid. Then so before we say if it's valid or not, right? It might be valid. We can say, hey, if wounded, we can tell them you have to sleep it off. Otherwise, if they're not wounded, right, then we tell them, hey, this is your valid command list. What do you want to do? Eventually, when they enter sleep, right, sleep should be a valid command. We'll go tell them what they did. So we can pass in sleep to our get valid command. We don't need flip here now. So if the command results, so else if my command, and this is why this one's harder. I don't recommend this approach, but this will be more useful later on if you want to make it more of an interesting game. You can do other things with the wounded status other than the only thing you're allowed to do is sleep. Or you could like track off when you're wounded, or if you get wounded 3 times, you die, game over, all sorts of other interesting stuff here. But that's okay. So if they entered sleep, we'll just say wounded is false, and we can return you sleep and feel better. Sure. You sleep and feel better. Awesome. We'll end that one, and then this was our else. Here, I think I butchered that a little. One more parenthesis. Okay, we match, curly braces, cool. So sleep is okay, or if you're wounded and you didn't enter sleep, we will tell you, hey, you have to sleep it off. Here. If you're not wounded, then it doesn't matter, right? Because this is false. False on anything will be false. We won't care about that. It's not going to make the loop run unless it's otherwise invalid here. So it's putting the check in a different place here. So now we can run this. And oops, where am I missing a semicolon? There we go. Give that a shot. There we go. What do you want to do? So if we let's go north. You go north. If we sleep and feel better. Now we can, so we essentially have added sleep as another action. We can do anytime, which is okay. Like you can probably sleep anytime if that makes sense for your game. What do you want to do? So if we jump, we jump. If we flip, hurt yourself. You need to sleep it off. What do you want to do? I want to jump. So you have to sleep it off. What do you want to do? I want to go north. You have to sleep it off. What do you want to do? Okay, well, let's sleep. You sleep and feel better. What do you want to do? Now can I go north? Now I can go north. Sorry, it's all the way down at the bottom here now. Oh, that's yeah, find out like. I wonder if I can put that on the side. Different option. So I'm catching up on chat here. If you have your game and do a direction, random event based on the action, that's much more interesting, for sure. Tone, if random events happen, it's more complex than we needed to do, but super cool and a much more interesting game if different things can happen. Yeah, so using the Boolean value is fun, and then you can do other things with it and other commands, and like, hey, if you want to jump and you're wounded, you can do other, like, I don't know. Eventually, it could be more interesting. If we only have that happen inside the flip method, that's the only place we can do anything with it. So moving it out gives us more options. Again, just an alternative here. So this is with Boolean for wounded. That one probably made your head hurt. I'm sorry. It's interesting, but I don't expect anyone to have that. Just the right inside the other command was fine here. That's pretty easy enough. Okay, so we got 3 different versions. They all work. They all get the points. They're okay. And if yours is different than that, that's okay too. Right? We're just going off the rubric as we go. So questions, thoughts, concerns? How'd this one go for you? Yeah, not great. I got fun. I got terrible. I'm sorry.
Game of the year.
Still I going? Game of the year. Yeah. So if this didn't go well, think to yourself how much time you're putting in. Again, 4 hours a week in class, 8 hours a week outside of class is the average. And that's average. Some people are going to take a little more, some people are going to take a little less. If it's taking you like 10, 12, 15, 16, something's probably wrong, and we should chat. 8 to 10, that's okay. If you're getting done in 6, great. If you get it done in 2, fantastic. That's okay. As long as you're getting things done, that's great. It's going to be different for everybody. But we have tutoring available. We've got our group tutor sessions Tuesdays and Thursdays with Mr. Tim. He's specific just for my class. And so everyone in the class gets to answer questions along with the 3 online sections. So there were 120 of you. We've lost a couple now. A couple of folks have dropped. So it's, I think, closer to about 105 now or so. People taking 1,500 that could possibly attend these sessions. I don't think more than 5 usually do. But Tuesdays and Thursdays, 5 to 6 over Zoom. And then the individual tutoring sessions. Right? Auburn Hills and Orchard Ridge. So Auburn Hills has 1 CIS tutor. You can go to meet with Andre Monday, Wednesday, or Friday. Or Orchard Ridge, we've got a bunch of people who can do 1,500, thankfully. So if you just search for 1,500, or probably CIS 1,500, it's better, right? I thought we had more people than that. No? Oh, okay. So yeah, so CIS 1,500 was the wrong. That's fine. Yeah, so Rika, Jordan, Tim as well also does individual appointments. You can meet with folks there. It's fantastic. So take advantage of that if things aren't clicking for you. They've got an hour to spend with you. My appointments are usually about 15 minutes or so. So let me go back. Right, you can come to D2L, go to the course information content section here. I've got a link to my Calendly page. I love this little website. It's really fun. You can schedule office hour appointments here. It says so Mondays and Wednesdays evenings, 9:30 to 11:30 or so. You can do a 15-minute appointment, or Tuesdays 4 to 5:45 or so. I'm like just down the hall here in my office. But we can also meet virtually as well on Discord or Zoom is fine. If Monday, Tuesday, Wednesday doesn't work for you, I can meet other times, so shoot me a message with a couple days and times that work for your schedule, and I'll see if one of them will work with mine. Happy to do that if we need to. Would prefer these ones, but again, I'll try and be flexible and do what I can for you folks. But I'm about 15 minutes or so for everybody because I've got 120 plus students or so I got to work with. So the tutors can meet with you for an hour. It was a great resource. And then let them know or ask them kindly if they could let me know that you came, and you get the bonus point for going. So I get attendance reports from Tim for the group tutor sessions because he has to fill those out anyway. The individual tutors don't do that unless you ask them. So to say, hey, could you shoot Eric a message? Let them know we met, and I can get you down for those extra credit points. So take advantage of those. Unfortunately, things only get harder from here because we don't get to forget any of the stuff. So if it's shaky now, it's not going to get better, right? You've got to solidify what we've done so far to make sure it feels good to be able to move on and be successful. As you saw with classes, it's all of it is using methods in classes, and we're going to do even more stuff with that. So if methods didn't really click well for you, last week was probably awful. This week will be bad too, because it's all more methods, that sort of thing. So we want to get you caught back up to speed, get you solid before we keep on moving on here, because it just piles on like a math class, right? You just keep on building and building and building. So we're going to keep using methods. We're going to keep using classes as we go for every one of these projects as we keep going, and eventually the final project. We don't get to forget anything. And then next class, if you do continue on and take like object-oriented programming in Java or something else, you use all these tools and techniques, right? And as you learn other languages, the tools and ideas and concepts still apply. You just learn how to do it in the other languages. So a lot of fun stuff coming up. We do have winter break coming up, thankfully, so we'll get a little break after this week. That's a good chance to get caught up, right, and see how things go. We don't have the midterm until near the middle, end of March here. It's a little later, but I want to get through the main content, do the midterm, and then get into the final project stuff. Graphical user interface programs. They're a lot of fun, much more interesting than typing text in, because typing text into a black box here is really boring and not very common anymore. Most programs don't look like this that people use. So there are still some, and specialty places do things like this, and there's a lot of utilities and other things you can do with command line programs, right, where you're running at the command line or the terminal. They're great, but for the average user, they're just going to look at you funny, like, I don't know what I'm supposed to do here. Why do I see a black box? What do I click on? You're like, no, there's no mouse. You just type, and then people get really sad because they like to use their mouse to click on things. So, and that's okay. That's kind of what we're used to. So, all right. Let's see. Midwinter break. Yeah, next. Yeah, so that's next week. We're off. I'm trying to keep up on chat here. I'm sorry. So it's half quiz style questions, the weekly quizzes that we have, and then half long answer programming questions. Write a little bit of code that does this. It's designed so that you could take it in one sitting in class if I wanted to watch you take a test. I don't like to watch people take tests. It's terribly dull. And no one likes to have people watch them take tests either. It's just stressful. So we're not going to do that. It'll just open that night. You'll have all week, like the weekly quizzes, to open it, start it, come back to it, close it, save it, come back to it later, go to bed, wake up, open it. So as long as you get it in by the next week, you'll be fine. So it'll open 321, be due on 328. So we'll have the whole, nothing new comes that week. You got the whole 4-hour block plus the 8 hours worth of extra homework time. Hopefully you can get caught up on other stuff or work on projects and things, and we can go from there. So yeah, I literally use the same test bank for the quizzes. So yeah, but that's half, and then half like right, and so I'll give you last semester's midterm. Not that you folks would do it, but some people go to websites like CourseHero.com and post things that they're not supposed to post. So we're supposed to rewrite our tests every semester to avoid you going out and finding a previous test, which makes sense. Annoying I have to do the extra work, but that's okay. I don't mind rewriting the tests here. It's not the worst thing in the world. But if things just didn't get posted, life would be better. But again, it's okay. It's what it is. We'll move forward here. Yeah. Okay. Cool. So chat was asking about that as well. So all right. I got almost 7. We got to take a break now, and then we'll get into new stuff. Take 10. All right. Cool. I see one thumbs up. So we'll take 10 minutes, and we'll come back, and then we'll jump into the rest of objects and classes, and then we'll talk about project 2, and then we'll get out of here. Oh no, and the lab. Right, we got a lab this week as well. Every week. Is the only way to get better at coding is by writing code. Go figure. I'm sorry. So I put them out to midnight in case they weren't working great. Oh, that's right. We got to talk about the lab too. We'll talk about the lab when we get back. Ideally, they're done before class, but if something comes up, that's okay. If you're having trouble with them, we want to get it done during the week, ideally, because otherwise you're going to get behind. So, but that's okay. We'll get there, and we'll talk about the lab when we come back. Then remind me to do that. Let me put the music back on. Go from there. Until it's up. We'll just say 7 o'clock. Right. Bring it on back here. Right. So let's talk about the lab first, and then we'll get into the new stuff. So lab 5 on classes here. So we're going to make our bottle class here. So we start a new project.
I remember when I was ready my mom to
All right, guys, we're bringing it back. Bring it on back now, guys. So with lab 5 here, the only thing I asked for was the bottle class. So there's actually nothing here in main. You don't need anything here in main. Now, if you only write the bottle class and you don't put anything in main, you don't really know if bottle works. So we'll probably end up with stuff here, but all we needed was bottle. So that's what we're going to start with. So we're going to go over to the source folder here, and we're going to add a new Java class. We'll call this one bottle. Remember, name of the class matches the name of the file. So bottle.java, public class bottle. We're going to have a bunch of attributes, right? So we have attributes for max volume in milliliters. I hate that word, but I keep using it because our other system is terrible. Current volume in milliliters and beverage name. So this is a string, this is an int, this is an int. Okay, so we want a private int, right? These are private attributes that we're going to control access to. The idea with this object-oriented programming, we're going to encapsulate all those details together into one nice little package, and then we're going to give you public methods that you're allowed to use that control how you access these things. This is our current volume. I'm just going to copy paste here because that's easier. Max volume, sure. And then a private int for my current volume in milliliters. And then a private string for, is that beverage name or something?
Yeah.
Beverage name. There we go. Beverage name. Great. Once we have our attributes now, if you're not a fan of typing, IntelliJ to the rescue. We don't have to type anything else. So we can come in here and I can say I want to generate getters and setters. So a couple things though, right? With beverage here, we want get and set methods for everything but current volume in milliliters. We don't want to set directly. We don't want someone to say, hey, here's your current volume, right? The way that we're going to interact with that current volume is by having a method for drink here. So you can drink from, and then you'll also have a method for fill. So the way that current volume changes is by drinking from the bottle or filling the bottle is kind of conceptually how we're thinking about it here. So gets and sets for everything except for current volume, but I'm just going to go back and delete it here because otherwise I have to do something else. So set the current volume we're just going to get rid of because we don't want that one. But now I can get the beverage name and I can set the beverage name. So when my cup is empty, I can go refill it with water. I probably should get water after this because I've had a lot of coffee today. You might have noticed. Sure. We can get the current volume here. So you can ask the beverage or ask the bottle, hey, how much is currently in here? It's maybe half full, so I don't know how many milliliters that is. We'll say 150. Sure. The set max, now this is probably doesn't make a lot of sense, but sure, if I just like cut the top off of here, I've changed the max volume. Sure, so maybe we allow it. Again, this is, as we're defining our classes and figure out how we want people to interact with them, if you want them to be able to change it, you give them a public method. If you don't want it to change, don't give them a public method, right? Just say that you can't change it. So great. So then we'll have a default constructor and a constructor with parameters. Remember, default constructors don't take any arguments and they give some default value. The constructor's job is to give values to your attributes. So you don't want nulls. Nulls are bad. And you want sane defaults. And we can generate those as well. So I'm going to go generate a constructor. If I pick nothing here, select none, this is the default constructor. It takes no arguments. Now I have to go and say what these values should be. So my beverage name is probably blank. It doesn't need a name because it's empty. There's nothing in it, right? My current volume in milliliters will be 0. And my max volume, I don't know, probably 0. You could default that to 100. You could default it to 1,000, 2,000. I don't really care, right? If you want to pretend you carry around a 2 liter, great, 2,000 milliliters. Have at it. Whatever default makes sense to you, go for it. It's okay. I didn't specify. Then we want a constructor with parameters. So the shortcut way of going about this then, so instead of saying, hey, I want a bottle and then bottle set beverage name and bottle set max volume, is nicer if your constructor takes those as arguments. So we're going to generate again another constructor, and I'm going to pick all of them and say, okay. So if you give me the max volume, the current volume, and the beverage name, I'm just going to take them. Fantastic. You told me what they are. I'll accept. Cool. Now, we didn't do any sanity checking here to say, hey, if you told me the max was a 2 liter, 2,000 milliliters, and you actually said the current volume was 10,000, we're just going to accept it here because we didn't check for it. That's a good thing to check for, but I didn't ask for it at this point. Yeah.
We said under the lab 5 assignment, we just need to submit our bottle class.
So technically, the only thing required is the bottle class. Okay. When you give me the repository, I'm getting everything anyway.
Okay.
But if you didn't put anything in main, there's no loss of points there because I didn't ask for anything in main. You probably want to use main to make a bottle and see if it works, and see if you can drink from it, and see if you can fill it, and see if those values change. Because why write the code if you don't know if it actually does anything or not, right? Usually you hit run, and on bottle, there's no run button. I can't run bottle. Nothing's here. Remember, when you run a Java program, it looks for public static void main string args for where to start. This is the only thing that will run when you run a Java program, is this part here. This is the launching point for Java code. So, all right, so in bottle, right, we got all these. So you tell me what the attributes are, we'll go take them. Fantastic. We got all the other sets and gets. Those are ways of getting the values, changing the values. Now we need drink and fill, right? So when we drink, we need to make sure that you have enough, this milliliters to drink. Hey, how much do you want to drink? I want to chug that 2 liter. Give me 2,000 milliliters. If I have 2,000 milliliters of current volume, great, we'll go ahead and do it. If you don't, I'm just going to tell you, no, didn't work. Right? Just going to return false right away. But if we do, subtract that, right? Change the current volume. If you drank 500 milliliters, great, we're going to subtract 500 milliliters from your current volume. We're changing what's currently in the cup, right? Less milliliters. Okay? So let's do that one. So this is drink. So this we can't generate. We have to write by hand. That's okay. We'll write a lot of methods by hand, not too big of a deal. You right click and go to generate. And you can make getters and setters, or just getters, or just setters, or constructors. The other ones don't worry about for now. We'll come to them later. So we'll write public. Now, if this is going to return a value of true or false, it's a Boolean, right? Public Boolean drink. And I need to tell it as an integer how many milliliters to drink. Milliliters to drink. So when you call this method, you have to give it a number here of how many milliliters you want to drink. So I can check real quick. Hey, if the milliliters to drink is greater than my current volume in milliliters, I'm just going to return false. Didn't work. No good. You wanted to drink a whole lot? I don't have this much. No. Otherwise, right? So you might put an else here. You don't need to put the else here because as soon as you hit a return keyword, your code stops running. So the else is redundant at that point. A lot of people put them in anyway. I try not to, and that's okay. That's just a style preference here. Everyone's going to do it a little different. Otherwise, then I can take my current volume and subtract the milliliters to drink, and then I'll return true. Say, hey, you had a good drink. Go for it. You drank your coffee. Life is good. You drank your whatever, right? We took that out of the current volume here. Great. And I know because I checked to make sure it wasn't greater than, I will have a 0 or larger value, which is valid for a bottle. Right? If I wasn't checking this and I just subtracted the value, you might end up with a negative current volume, which breaks the laws of physics, and the world will crash. No, I'm sorry, but bad stuff will happen, right? The idea of our classes and why we write classes and why we do this object-oriented programming is so that my class can protect its integrity. Right? The bottle class depends on current volume being between 0 and a real number. It can't be negative because then it doesn't work. So we write in our code to make sure that happens and make sure we don't get into an invalid state. That's the other benefit and why we like object-oriented programming. Yeah.
You don't need to put an else there?
No, because if you hit this return, it's done running.
So return is kind of like a break.
Yeah, it ends the method. Yep. Yeah, kind of like a break for a loop. It just stops. Yep. So else is fine. I think IntelliJ will even tell you it's redundant at that point if you add an else. I think you get one of those hints. Does it tell you? It doesn't. That's fine. I'm going to take it out though. The further stuff gets in tabbed, like the more uncomfortable you should get, for lack of a better word. 3 tabs, sure. 4 tabs, 5 tabs, ugh, that's real bad. And again, now that we have methods and things, we don't have to go that far. You can break it up into smaller pieces here, so that you don't have to have 5 or 6 or 7 tabs in, because that just gets really awkward.
This one, you don't have to add else statement.
Yeah, because if you hit return false, method stops. It never gets to this line. If it's not true, then we'll run these 2 lines, and life is good. All right, so it's drink, and then a Boolean for fill. Right, fill takes a milliliters. Oops, int milliliters to fill. And the idea with fill, right, is make sure we don't overfill. So if you want to pour 2,000 milliliters into this bottle here, you're going to spill all over the carpet and waste good coffee, and I will cry. That's a sin. You can't waste coffee, right? Not allowed. So we're going to make sure before you try and fill the bottle, we're going to tell you yes or no this will work or not. Okay. So if it doesn't overfill, so the logic here is a little different here. It's not just, hey, is it less than this? Is what we need to do. We're going to check, hey, if my current volume plus the milliliters to fill is less than or equal to my max volume, right? If you take what's in here, add the new stuff, as long as it's less than or equal to the max, you're good to go, right? So this case, we're checking if it's okay first, rather than if it's bad first. Either's okay, right? You could do either approach. So this is a good state. Yes, you have enough room. You could also flip it and say, hey, if it's greater than, it's a bad state. We'll tell you no. Either works perfectly fine, right? Either approach will just return false. Say nope, you went over the max here when you added those two together. Don't do it, right? Don't put 15 gallons of gas in your tank if you already have 5 gallons of gas and you have a 15-gallon tank, right? You don't want to waste good gas, right? Otherwise, then we'll take our current volume and we'll increase it by the milliliters to fill, and then we'll return true. Hey, yeah, life is good. You added 100 more milliliters of coffee. You got your refill. You left a little bit of room for cream and sugar. Sure, go for it. It's not the right way to drink coffee, but that's okay. I try not to judge too much.
How do you drink your coffee? Yeah.
Straight, just black.
I hate it.
Oh no, that's so. When I got my first full-time job,
I've only had
I worked at the Auburn Hills campus. Actually, I did IT support, and the boss at the time, the office was like inside the library for I don't know why. So there was no drinking fountain. There was no water that you could get. To get water, you had to leave the office, leave the library, go out into the hall. So if you wanted something to drink, there was the coffee pot, because the other guys in the office drank coffee.
How old are you?
18. Yep. So all the guys in the office, except the boss, drank coffee black. The boss would bring in special cream and sugar because that's how he liked it, and everyone made fun of him. So I'm like, oh, I can't drink it with cream and sugar. They're gonna make fun of me. So I started drinking black coffee. That's what went through my head.
You only
Like,
drink it because of a hive mind. Yeah.
I like it like this now. Without cream and sugar is better for my diabetes anyway. So yep. So that started. So, and after I moved out, I had to buy my own Mountain Dew. I used to drink a lot of Mountain Dew for caffeine, and once I had to buy it myself because my mom wouldn't buy it for me, I stopped drinking Mountain Dew because it was expensive. The coffee was free because the other guys in the office made it. So
Francis guy, like the one video from years ago, he's like, "You drink my Mountain Dew? Let me show you brand."
I used to drink a lot of Mountain Dew, yeah, but it's expensive.
2-liter Mountain Dew 2 years ago. I stayed up all night.
Oh yeah, cream soda's pretty good. So I'll drink diet pop, but it's not the same. All right, so we got drink, we got fill, we got ways of interacting with bottle now that will change the current volume. Now we can actually see if it works. So now if you want to come over to here in Maine, we can. So we'll make a bottle and do something with it. So let's make a bottle. Let's call this coffee equals new bottle. And let's give it some values here. Oh, I'm sorry. So we have to give it the max. We'll say it was 250. The current was like 100. And say it's coffee. Right? Again, this is why you want good variable names. IntelliJ will tell you what these mean. So max was 250, current's 100, beverage name's coffee. Great. Now we'll try and drink. So we can say, hey, if coffee.drink, and let's drink, 50 milliliters. And we can spit out here. You took a drink. Took a drink. If it doesn't work, right, if we get back a false result, we'll say not enough coffee to drink. Coffee to drink. Big sad. Okay. Now again, I know this will work because I gave it 100 and I'm only asking for 50. But if we were asking the user to say, hey, how much do you want to drink here? Or getting a random number or doing something that wasn't just hard coding a number here, we could get a different result. So this is not very interesting right now because I know it works, but that's okay. And we can just do it again here now. So if after I drink 50, if I try and drink 100, it won't be enough. So I should get, you took a drink and then not enough coffee. This is the first time should work because I had 100. I drank 50. We're down to 50. I try and drink 100. 100's more than 50. It should tell me no, not enough coffee to drink because I should get back a false result. So what's fun here in debug mode, if I put a breakpoint here at line 5 and run with debug mode, so instead of just hitting run, you go to debug, you can watch it run and you can watch it jump between your files. That's the fun part. So instead of step over, I'm going to use the step into finally here. This is step into. I'm going to step into the drink method for coffee. So I see I've got a coffee here. It has a max volume of 250, a current volume of 100, and beverage name is coffee. You can see your attributes. If I step into, now all of a sudden I'm in my bottle file. In bottle, you have a this. Remember, this is your current instance. So I can make Eric's coffee, I can make Eric's Diet Coke, or I can make Eric's Coke Zero because I'm doing my taste testing to try and see which one's better. Coke Zero is better, by the way, but that's okay. As many different bottles as I want. You should see my desk at home. It's awful. I have like 7 different cups, and they're all like half full because I don't know. I probably have some sort of ADHD. I've never gotten tested for it, but like I'll start drinking something and I'll forget about it, and I'll go get another drink from upstairs. I'll bring it down. I don't know. It's all over. It's all right. So at this, you can open up this and see, hey, here's your attributes here. These are the values of this current bottle here. But now we're in our drink function, drink method. It says, hey, the milliliters to drink was 50. Milliliters to drink is 50. Great. We're going to do our check here. I can step. It is not greater than my current volume, so we'll change current volume. So now we'll see that change to 50 here. Right? 100 minus 50 is 50. And then we'll step. We return true. And we can step. Now it'll say you took a drink. Cool. That one runs. Now let's try drinking again. We'll step into. Milliliters drinks 100. Current volume is 50. We're going to get back false because this is now true that 100 is more than 50. Cool. We get back false. And we say, not enough coffee to drink. Big sad. We go back to the console, and our program will be done. So you can watch it run here, which is really fun to see step by step by step what happens inside your code. So now we drank. Now we can try fill as well, right? So let's try and fill. So we'll say, hey, if my coffee.fill, and it had 50, the max is 250. We should be able to 200 more in there, right? Say you refilled your coffee. We expect this to work, right? Because I should have enough room to add 200 more if I'm down to 50, right? Just kind of, I know what the value should be because we started at 100, took away 50. Now we can add 200 to go up to 250, right? And then else, don't spill the coffee. So at home, I have a thermal pot, which is super nice because it keeps it hot without like the burning flavor. The downside of that, though, in the morning, if you forget to check and you didn't drink your entire pot the night before, and you start another pot of coffee, it just puts it on top of the old stuff and it overfills your coffee pot and you get coffee all over your counter. The kitchen smells delicious, but you got a mess to clean up. So I'm sensitive to spilling the coffee here because sometimes you're just too tired. Let's do it again. So after I filled, let's just try it again here, and it'll tell us we're about to spill because we should be at the max. So if we run that one, we refilled, and then, oops, too much, don't spill the coffee. We got to this else, it was not successful. We got back a false. So don't do it. Okay. So depending on where we're turning a true or false, we need to do something with that true or false inside of main if we care. Right? So maybe we have some sort of loop going on here. We might say while it's false, keep on asking the user, hey, how much do you want to add or how much do you want to drink? We've got all sorts of different choices, things that we can do with this value here if we're asking the user for input. And again, none of this asks the user for anything. I'm just putting in some values to see if my methods work because I just want to test it out right now. Later, we could do something interesting and we can make different bottles and say, hey, you have a whole collection of things to drink. What do you want to drink from? And don't drink the blue potion because I don't, whatever, right? What does Alice in Wonderland drink to make her small? I forget. Oh, she eats a mushroom or something?
Yeah.
She eats the cake to get really small. So we can do all sorts of silly things like that. And you can have different collections of things, and you know, we can have lots of different bottles. that changes your size. Yeah. Yeah.
So for a model copy program, that's the same numbers, the same number class.
I'm not sure I understand the question. I'm sorry. So we have the bottle class can have any values for these. I can just make as many different bottles as I want to have in memory for me to use in my program. So I could have the coffee, I could have a Coke, I could have a Mountain Dew, I could have a water, I could have my ice, sparkling ice beverage, and I could drink all of them, right? Sure. All right, so that was the lab. Yeah.
So obviously we're using the constructor here.
Yes.
What would be the instant attribute?
So these ones here that are private are my instance attributes. So unless it has the word static, they're instance attributes. They belong to each instance of the bottle class. So every time you make a bottle, it gets its own set of these attributes here.
Thank you.
If you use that static keyword, they belong to the class, and you only have one of them, and they're shared among all the instances. So we try not to do a whole lot with static in this class because it gets weird. That's generally a topic for the next class. You get a little further into that. All right. Awesome. So we go with this committed here. So here's lab 5. Commit and push. All right. So picking it up with sections 5 through 8 out of chapter 5. Inheritance is important. We need to understand what it is. You're not going to do a whole lot with it right now because when we get to our graphical user interface programming, we'll take advantage of inheritance. We don't need to do anything custom with it, but we'll take advantage of it. So we need to understand, be able to talk about it. Inheritance is one of the fundamentals of object-oriented programming. Same with this polymorphism idea. That's a real fancy word here. We'll get to it briefly. More often, that's a topic for the next class as well. The this and super keywords, this we looked at, right? This means the current instance. Super will make more sense when we talk about inheritance. Interfaces, we're just going to skip. We don't even need to talk about them at all. That's later on. You can get to that in another class. And then nested classes is kind of ugly. Generally, you don't do this as much. That you can do some interesting things with them. But for our purposes, we're going to basically ignore them as well. So know that they exist. Something you can do. We don't need to do anything with them for now. So basically, we're looking at 5 and 6, really. And maybe I should edit that to make that a little more clear. The other ones are good. You can like skim through it, but don't feel like we're going to go deep on any of those. So it shouldn't be too bad. And then we'll talk about the lab, and then we'll talk about the next project. Okay? Yeah. So project 2 starts this week. It'll be due 3/14. So assuming winter break doesn't happen, you'll have 2 weeks to work on it, like usual. So feel free to take the week off. It's good to get some time off to be able to rest and relax. That's important stuff for real. Yeah, it's hard, but so we'll try at least give you the time aside from that. So, all right. So we start up a new project. So this is week 7. We're in week 7 already. Holy cow! We're halfway there, right? Because week 15, actually week 15 we don't do anything. It's just final project work time. There's nothing new. So this is halfway through the content. Believe it or not, we are cruising through. Just fun. And then the final week, I finally shut up, and you folks get a chance to talk. So, and then play your fun games, fun, interesting games. Fun is a bit of a stretch there, but it's something. It's game-like. That's all. That's the goal. Game-like. Okay. So week 7, we start that up. New project. This is week 7. Last is part 2. All right. Here's main. We don't need to do anything in main yet. We'll come back to main. Right? We're going to do a new class. So I'm going to make a new class here. I'm going to make a class for mammal. I think mammal has 2 M's, right? All right, mammal. Awesome. So things about mammals, right? As we think about the noun for mammal and attributes of mammal, right? Yeah, live birth, right? Mammals give live birth. Although, are platypuses mammals? Aren't they debatable? Biology is hard. Biology is really hard. But in general, so mammal, right? How about mammals make noises? And so maybe we'll have a private string for the noise. So some sort of noise that you make here. Like dogs will bark, cats will meow, people will talk your ear off until you fall asleep because they're boring. Sure. Yeah, and so maybe we have a string for hair color, maybe? Mammals usually have hair, I feel like. Sure. So we got some noise, we got some hair color, and then they probably have a name, right? Because we like to name things. I think so. That you have a skeleton. That sounds right. I think this is probably good. We don't need to get too many details here. So we've got a couple. Okay.
We breathe air.
Oh, I'm sorry.
Air. We breathe air.
Yes.
Even the ones that live in the water.
Yeah, whales, right? Because whales are mammals. Yeah.
They're capable of homoregulation. I said that wrong. Basically, they can regulate their body temperature.
Yeah,
and
regulate body temperature, warm-blooded. Yep.
Thank you.
So all things about mammals. So you understand mammal as a concept, right? And we got attributes for mammals. So each mammal can have its own unique instance of this here, right? That's fine. So let's go and generate a bunch of stuff because I don't want to write the code myself. Generate constructor, we'll pick them all, sure, and then we'll get gets and sets. Generate gets and sets. I'm just gonna make everything here. You can change your name, you can change your noise, you can change your hair color. Yeah, I'm sure you could dye anything, right? You could have a blue sheep if you really wanted to go dye a sheep blue. Sure. Okay. So cool. So now we can use mammal. Now, if you're familiar with biology, mammal is a general category, right? And there are subcategories of mammal or special kinds of mammals, right? This idea you have kingdom, phylum, class, order, family, genus, species. I don't know why that's in my head, but it's been in there since biology class. And sure, it's fun. So special types of mammals, like humans and dogs and cats, right, or whales, we're all mammals, but we have our own distinct set of properties. So if I wanted to make a class for dog, I could go write a class for dog. Dog also makes a noise. Dog also has a hair color. Dog also has a name. But what makes them unique here in this category of mammal is we might have these, I don't know, species of dog, and we might have the, I don't know, eye color for dog or the height that they can jump or something. Because when you talk about whales, there is no height that they can jump. Whales don't jump, right? They can like swim. I don't think that counts as jumping, right? So there's other attributes that are unique to that species, that sub-classification of mammal for dog. So I don't want to have to reinvent the wheel. I don't want to have to write all of this again here. So what I can do is I can take advantage of inheritance. So inheritance means I will be a kind of mammal, but I'll be a special kind of mammal. So we're going to write a new class here. So this will be dog. Which actually, I think that the technical term there is canine, right? Or something, whatever the Latin word is for that. So when you want to use inheritance, you say, I am a type of this class. So we'll use the keyword, and I can never remember what it is here, so I'm going to take a look here. Extend, yeah, okay, it is extends. So we'll say dog extends mammal. So now at this point, dog is a mammal. This inheritance creates an is a relationship. Whales are mammals. Is a mammal. Dog is a mammal. Cat is a mammal, right? It's an is a. It's not a has a, right? Eric has a coffee. Eric is not coffee. I've not consumed that much coffee yet to turn into a coffee, right? But I have a coffee. So it's a different kind of relationship here. Like coffee is a beverage, right? Coke is a beverage. There's certain things that all beverages will share in common and things that make them unique, right? That sort of thing. So right now it's yelling at me and it's upset. It says, hey, there's no default constructor available in mammal. I'm going to go just work around this real quick because we want to make this easy for us. So I'm going to go generate a default constructor because life will be easier this way. And then we'll get into what we can do otherwise. So I want none. So here's my default constructor. So we'll just say noise is nothing. Remember, the constructor's job is to give your attributes default values. Nulls are really bad. So strings will give you nulls, and then nulls will crash your program when you try and use them. So I'm going to set them to blank until I know otherwise. Hair color is nothing, and name is nothing. Okay. Now that line goes away because there's a default constructor available. We'll come back to that later. But now I have dog. So what makes dog unique? We said we have a integer for jump height in centimeters. Sure, this is how high your dog can jump, right? And maybe we have a string for species, or is it breed? I think it's breed of dog, right? You say this is the breed of dog here. I don't know. This is probably fine. How much they slobber in milliliters? Let's not think about that. That's okay. That's fine. So what I can do now with dog, right? Let's go generate here a bunch of code because this makes life easy for us. Getters and setters. Great. And then we want a constructor, right? The constructor's job is to give values to our attributes. So we'll do a constructor that takes parameters and one that doesn't. Now, I'm sorry. I got ahead. So when I generate a constructor, it says, hey, which superclass constructor do you want? So the technical term here for this relationship between dog and mammal is the superclass, dog is the subclass. You might also say mammal is the parent class, dog is the child class. You could also say, because you have like 3 ways to do everything in programming land, that mammal is the base class and dog is the derived class, derived from the base class. It is the child of the parent class. It is the subclass of the superclass. I get confused by the terms all the time. I'm going to use different ones every time. I try and stick to super and subclass because we'll use the word super, but they're interchangeable. So which one do we want to use? So if I want the default constructor, I want the default constructor of mammal. And I don't need anything here. So when you make a dog here with no arguments, we'll say my jump height is 0 and my breed is just an empty string. Cool. if you want to make dog that uses this mammal constructor here that has the noise, the hair color, and the name, we can do that as well. So we're going to use this generate again, do a constructor and say, hey, I want this mammal's constructor here, and then I want all of mine here. And it says, okay, sure. You tell me the noise, the hair color, the name. You're like, oh wait, these aren't part of dog, they're part of mammal. Sure, that's fine, we'll come back to that. And you tell me the jump height and the breed. And what it does, it uses this super keyword. Notice it shows up in orange, it's a reserved word in Java. It's a special thing. It means go to the superclass and run the constructor. Sure, so go to your superclass, go to the mammal class, the class that you extend, run the constructor and hand it noise, hair color, and name. So mammal's constructor for noise, hair color, and name will run. We'll give it these values here. Then the rest of my dog stuff will happen here. I can accept those two values here. So if you're going to call a superclass constructor here, this calls the constructor in mammal, be the first thing you do. So if you want to call a constructor, it has to be the very first thing that happens. If you don't have this be first here, oops, Java's going to yell at you. If you try and put it down here, it says, nope, can't do that. Super must be the first statement in the constructor body. Has to be first. So the idea is your parent class, your superclass, has to create all of its stuff first because you might depend on it. Java has no idea whether or not we do, but it says if you want to use that constructor, it has to happen first. So we'll just go back, put that at the top in a constructor. I'm sorry, I should not have been yelling here. Must be the first line in a constructor. Right? This super keyword. Now notice this one doesn't use the super keyword. It's technically doing it automatically. If there's a default constructor, it's run implicitly. So implicitly. There we go. One of these times I'll spell it right. Spell check's amazing. Runs super with no arguments. So this happens automatically. Java just does that for you. It says, oh, if you didn't ask for one, you probably wanted this one. Because by the way, you have to call a constructor. Okay. So cool. So we can say, all right, hey, here's the noise I make. Here's my hair color. Here's my name. By the way, this is how high I jump. This is my breed of dog. So back in main now, we can actually make dogs and we can make mammals. We can have a mammal for, what do we want to, what's a fun mammal? Marsupials are mammals, right? We can make a koala. Wow. That's fine. So equals a new mammal, and we have to tell it all the different attributes here. Or we could use this default constructor and then go use all the set methods later. And that's a lot of typing, so I'd rather not do that. So let's use, so in mammal, we have to give it the noise, the hair color, and the name. So what noise does a koala make?
Sounds like they munch.
Munch?
Never heard them make the noise.
Munch on eucalyptus?
They make it.
We'll just say munch, because I don't know. Munch on eucalyptus leaves. Oh, I remember now. This is a free one. Why aren't koala bears technically bears? They don't have the qualifications. Oh, yes. That one is so good. It's one of my favorite ones. I like it. Ancient Bags, the plans to edit the online textbook. I don't want to edit it while people are actively using it, so I have to figure that out still to take out the stuff that we're not going to use right now. Cyber, we can talk about that later. Scheduling. All right, so mammals here. The hair color, right, for mammal, it's gray, right? Now, is it EY or AY? Because they both are good, right, for gray?
Yeah. Which side of the pond you're from? British people are such inferior.
What's the British way of spelling it?
There's also
With an E?
Yeah, gray is A.
Really?
Yeah. It's kind of like color.
Gray versus gray.
When you're British.
No difference. Uh-oh. American English and British English. Huh. Interesting. Merriam-Webster.com. All right, let's consult the expert here.
Well, it's like people who spell color with a U.
Color. That's fancy. Okay, that's fine. Gray. All right, and then the name. What's our koala bear's name? Bear. We'll call it Bear. All right, so I've got a koala. So koala dot, and I get all the methods here: get hair color, get name, get noise, set hair color, set name, set noise. Those are the methods we wrote in mammal. Great, now we have a mammal. If I want to make a dog here, so I'll say dog, and this will be my dog's name was Pepper. Will be a new dog. So wolf, 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 wolf. I don't know. Wolf, wolf. I don't.
2 O's, 1 F.
2 O. Woof, woof.
Yeah, woof.
No, woof. My dog said woof, not woof.
Pork. You're the part of the dog shop?
So she was actually part beagle. She was a beagle lab mix, so she would like yowl. She was awesome. All right. She was black and white.
Dog now? You throw it out.
Her name is Pepper. And then dog also now needs the jump height in centimeters. She was a lab mix, so she could jump pretty easily high. I'd probably say she could jump onto the table. So that's what, 3 feet? It's probably a meter, right? So it's 100 centimeters or so. She would get dinner off the table and it would piss off my dad. So, but she learned not to. Eventually, we had to tell her not to get on the table.
What is it?
I'm sorry?
Corgi?
She was a lab and beagle mix.
A lab beagle?
Black lab beagle mix. All right, and then the last thing was the breed. So that was beagle, lab, what? What's 2 T's, right? I think. I'm bad at spelling. Sure. So great. So now we have a dog, so I can say Pepper dot, and now I get a bunch of things. I have get breed, get jump height, set breed, set jump height that we'd expect to see, but we also have get hair color, get name, get noise, set hair color, set name, set noise. These methods come from my parent, my superclass. Because I am a mammal, all the public methods of mammal are usable, right? We didn't need to reinvent the wheel. They just come with extending mammal, using mammal as my superclass. So any of the things mammal does, dog can do too, because it is a mammal. So we use inheritance to make less work for ourselves, right? You make a special version of that superclass with new unique things to it. This is what's unique to dog, right? They jump. When we make a whale subclass from mammal, they'll have a swim speed. I guess dogs probably also have a swim speed too, but that's probably more confusing than we care to get into, right? Sure. So we'll have what makes whales unique, a unique subclass of mammal, right? You can add in those unique attributes. So this idea with inheritance is you don't need to reinvent the wheel. When we get into graphical user interface programming, we will inherit from the graphical user interface program classes. We don't need to tell Java how to be a window or how to be a button or how to be one of these things. We just say, hey, I am one of these. And now I do special things because I want to put this on the screen. We're going to take advantage of inheritance. So you can go a lot further with it. You can do a lot of crazy things with it. This is enough for now. The last thing I want to show you here is this idea of polymorphism, which is such a fun word here. Polymorphism means you can treat something as its parent type and pretend it's like its parent type. You can say it is one of those, so you can treat it like one of those. So what I can do is I can write a method here, public static void, print mammal details. That takes a mammal called mammal, right? And we'll just print out, what do we have? Noise was mammal.get noise, right? And then we'll print out color and mammal.get color, hair color, and name mammal.get name. All right, so you can give it a mammal, and it will call the methods of mammal to get these details and do something with them. We're just going to display them here. What's fun now is I can call print mammal details and give it Pepper. Because Pepper is a mammal, I can give it to something that wants a mammal. I can treat it as its super type, its superclass here. Now, inside of this print mammal details, I don't have access to get breed or get jump height because the only thing Java knows is that it's a mammal. So when I say mammal dot, I only get the mammal methods. That's okay because all I wanted was the mammal details. So this idea with polymorphism is you can have a bunch of subclasses, and you can take this as far as you want, right? You have kingdom, phylum, class, order, family, genus, species. You can get as detailed in this hierarchy as you want. You can get all 7 if you want. You can have, I don't actually know if there's a limit. You can have subclasses of subclasses of subclasses of subclasses of until your eyes bleed, right? As many as you want. If you need a special version of the superclass, that has unique attributes and has unique behaviors. You can do that, right? But you can always treat it as its parent type, its superclass type, its base class type, because it fits. So Java says, hey, does it have these methods? Fantastic. We'll pretend like it's a mammal. It looks like a mammal, right? So we run this then, we should get out pepper details. Wolf, black and white, name is Pepper, right? Pepper's actually a dog, but Pepper is also a mammal because dog is a mammal. It's a fun concept. You'll get into it deeper in another class. Just know that this works, right? And that we'll take advantage of all of this stuff when we write our graphical user interface applications because we can be a window, right? And then you can have a window that you can drag around and click on and do things and add menus to and buttons to click on and places to type text and all that fun stuff. That's not typing on a black screen here because this is terribly dull, right? All right, so we can extend classes to create that inheritance relationship, which is a relationship. I know I've said it a bunch here, but it's a core concept, right? And then you can treat these subclasses, you can treat the child classes, the derived classes, as their parent type with polymorphism, which is really fun.
Extends, right?
Yeah, the keyword is extends in Java, so that one shows up in orange here. It's extends. Yep.
So if you want to string classes together, you just have to do extends.
So if you wanted to make a like Beagle class that extends dog,
right,
you would say public class Beagle extends dog, and Beagle is a dog, which is a mammal. So you don't have to say extends mammal again, because dog already does. Yep. Yep.
Okay.
Yep. So we can make a.
So if you picture like it's a box, my mammal's a box, dog is its own little box.
Yep.
String. Right?
Yep. Yeah, they're connected.
Okay.
It creates that is a relationship. So dog is a mammal, right? They're tied together now. So mammal is the parent class, or the superclass, or the base class. And dog is the subclass, or the child class, or the derived class.
Oh no.
Yep. Mammal's here, yep, and dog is a special kind of mammal. Yep. Hey guys, I can't hear the question right now. Sorry, what was that? Yeah, so when we talk about foundations of object-oriented programming, inheritance is a foundational concept in object-oriented programming because we define things as objects, right? Here's a chair, and then I might have a subclass of chair for chair with wheels. That is its own set of unique attributes and things. Car, oh, yep. Yep. I'd imagine Nissan is more attributes of car, like who's the make and the model. A subclass of car might be, hey, this is a coupe. It has unique attributes specific just to coupe, or maybe I have a convertible as a subclass of car with unique attributes to convertible. Does that make sense? Rather than, so like Nissan's more about your attributes. What about the car, not what makes it unique necessarily. That's like the model here. Or like you might have vehicle as a base class, and then you could have car as a subclass, you could have truck as a subclass, or you could have van as a subclass that all have their own unique sets of attributes that they have in common. Yeah. Yeah. Yeah.
Is that always the subclass? Is that always denoted by saying like main or public, whatever the class name is, extends what the other class is?
Yep. So extends is the word you use to create that inheritance relationship. Without the extends word, you don't inherit from. Yep. You're just a class without it. Yep. All right. Great questions. So inheritance, polymorphism, abstract classes, don't worry about. We'll get into that later. Not too big of a deal. And then the next piece, this and super, right? We've done this. This is my attributes. And then super is my superclass version. The other cool thing you can do here. Now, our mammal class doesn't really have an interesting method, right? It just doesn't really do anything interesting. It just has gets and sets, it has a bunch of attributes. But if we had a method for mammal, like, I don't know, how about public string make noise. And we say I want to return the noise, or I don't know what name makes a noise sound. Sure, right? Pepper makes a wolf sound. Right? What you get for my dog, right? We can use this make noise method. So we can put that in here in our print details, and we'll say mammal make noise, and that returns something, right? So we'll get out that result. Let's see if that runs. Yep. So Pepper makes a wolf sound. It's a method that does something. So if you want now, what you can do is also using that super keyword is we can change the behavior of what make sound does or what make noise does. There's a couple of cool things we can do. So with this one, we're going to say I want to public string make noise. So we're going to add a method with the same name as my parent class's method name, make noise. So what's going to be different about dog here when we make a noise, we'll also say, and they jump or something. I don't know, because the dogs, like as soon as you walk in the door, they jump all over and howl at you and yowl. So we will say, okay, now I don't want to reinvent the wheel. I don't need to redo all of this. I could here, right? I could return, name is red, right? I have a name attribute, but I don't have access to it. And it says name has private access in mammal. And in mammal, we said, hey, this thing is private. No one else can access name outside of the class. So even though we are a type of mammal, we don't have direct access to this. I can't get at the name because we've told Java it's private. So we'd have to say, okay, I want get name. Here, we can use the get name method and the get noise method, right? And then we'll say, and jump height in centimeters. Sure, we could do something like that. Now, notice this cool little icon here. It says it's a circle with an up arrow. This means it's overriding the behavior of my parent class. So in main here, when I call make noise and I run this, even though we've said, hey, this is a mammal, it doesn't run mammals make noise. So polymorphism lets me treat it as the parent class type, but when you run one of those methods, if you're overriding it, if you have your own special version of that method, Java says, oh, you actually are a dog, let me run dog's version. So while it's running, that's called at runtime, it finds the right method to run based on what the actual type is. Even though we said, hey, I just want this to be a mammal, it doesn't run mammal's version. It runs dog's version because we actually gave it a dog. So polymorphism lets me get the runtime version of my methods if I'm overriding them, which is super cool. So you can get that special behavior out, even though we don't know that it's special at compile time. When I compile this program, Java says, oh, sure, it's a mammal. I'll pretend it's a mammal here. But while it's running, it does the right thing, which is really cool. But this is a little tedious, right? To have to redo all this, and now if it changes, we get ugly stuff here. So what I'd rather do is I want my superclasses version. So I'm going to say, hey, I want super dot make noise. Remember, super is the keyword. What is my superclass? Hey, superclass, run your get noise method, and then stick on here and jumps here. So this way we don't have to reinvent the wheel. We can get the superclasses version to run. So if we run this in debug mode, we can watch it jump all over the place. So it's going to jump into dog, and then into mammal, and then back to dog. This is where it starts to hurt your head, and it's okay. You'll get into more of this later, but you need to know that it does work. This is one of those concepts with polymorphism. So we're about to call make noise, right? We have a mammal. Mammal is actually a dog, right? Java knows it's a dog here. It has a jump height, has a breed, has a noise, has a hair color, has name. When I step into, nope, not this one. Sorry, that is the print line. I don't want print line. Step out. Oh, goodness. All right. Shoot. Let me restart that. Sometimes the debugger is annoying. All right, step into, not this one, right? I want to step into, okay, I'm going to click make noise, step into make noise. Here we go. So this is dogs make noise because Java says, hey, you actually are a dog. I'll run the dog version here. Then the first thing it does is say, oh, hey, run my superclass version of make noise. So when I step into now, I get the mammal make noise. is we said, hey, superclass, run your version. Do your thing, please. That gives me a value back, and then I add my piece here, and then we'll print it out. We can get what actually runs in dog. Jumps 100. We should probably add centimeters or something here, right? Plus centimeters, and knocks you over. I don't know. Thankfully, she wasn't too large. Some dogs will knock you over, but why not? It's our code. We can pretend. My neighbors across the street just got a Chihuahua, a teacup Chihuahua, and I swear, like, I'd be scared to walk that thing because I would step on it on a walk. Like, for real, like, if you just step the wrong spot, if it runs under your feet, yep, they have to carry it. They have like a special purse for it. It's really cute. It's an adorable little dog, but my goodness. So polymorphism lets you do this. Now, there's another cool thing you'll see in code a lot of times. This is overriding. You can add a note to Java. So you should say @override. Java's going to check for you and make sure that it actually overrides. Because what's easy to do here is I might say make noise. Make noise is perfectly fine, but now this override says it doesn't actually override anything, dummy. You meant to override something, but you missed the mark because you had a typo. Java doesn't care if I have a method called make noise. Right? Java's okay with that. The make noise here is telling me it was never used, is why it's underlined. So the override mark is to check yourself and make sure that, yes, you meant to do it and you actually did do it. Otherwise, you get an error. So it's just a helpful, it's called an annotation. No, not hair color. What just happened there? Override. There we go. And now I have to fix my typo, make noise. Right? So you can do some funny things here. This is where like the light bulb is not helpful. Pull method make noise to mammal and make it abstract. Don't click that button. That's a bad button, right? You don't want to do this one. It's not helpful. So it's not always a good tip with the red. I clicked it. That's all right. I can undo. Make noise. So it'll check and make sure we do the right thing here with this override annotation. This is a annotation. So the compiler checks that we actually did override method. There we go. It's just a useful tip here. So gives us the checking. All right. So that's the super keyword. So again, you can do the superclass thing, and then you can do whatever you want. So in this case, the graphical dice extends his pair of dice example. Remember we looked at classes, pair of dice had 2 dice, and you could roll the dice. So hey, when I call roll for graphical dice, roll the dice. Do the same thing my superclass did, and then for me, draw myself. So he uses some graphical stuff early, which again, eventually I'll get edited here. That's all right, we'll work on it here. For superclassing constructors, right? You call super, give it the arguments. Now, sometimes you just know what the value is. You don't have to take these as arguments to give them to your parent class. So if you want name to just be dog, you can just give it dog every time. You don't need to accept an argument for name just to give it to your parent class. So if you think of like rectangle and square, right? All squares are rectangles. So we could have that inheritance relationship. It is one of these here, right? But if I tell square what its width is or what its length is, right? I don't also need to give it the other one. So if you imagine you had a constructor for rectangle that took a length and width to tell a rectangle how big it is, if you had a constructor for square, you just need length, and you'll tell your parent class, hey, your length is the length, and your width is also the length. Right? And we can write those real quick. Those are quick. We can write a rectangle and a square. So here's rectangle. So we'll write private int for length and private int for width. And then we'll make a constructor. We'll generate a constructor that takes length and width. Sure. And then we'll write some gets and sets. Why not? Generate getters and setters. Sure. Again, we should add some sanity checking to make sure you can't have negative values, but that's beyond our example here. And I'll make a square. So square extends rectangle, right? Our keyword extends here. Nope. Oh, goodness. Rectangle. Rectangle. There we go. Square extends rectangle. And now it's upset with me. It says there's no default constructor available in rectangle. If there is no default constructor, you have to have a constructor that calls it, which is okay. So when we said With mammal and dog, it had that red line. I said we'll worry about it later. So what that means is I need to have a constructor for square. So I'm going to go generate a constructor. I don't need a length and width though. This is not the one I want because squares can't have different length and widths. So this generated code here is garbage. So it's no good. Squares, you just tell it how long it is, and we just tell my superclass, hey, by the way, your length and the width are the length because they're the same. You're a square, right? So I'll call my superclass constructor, giving it these values. Right? You don't have to have the exact same parameters just to hand them up to your parent class. Right, and other fun things, right? You could have public int get area, right? Returns length times width. Sure. Or get perimeter, like int get perimeter. Return length plus width times 2. Right? Sure. We can calculate it. So now square, because it is a rectangle, has get parameter and get area already. Right? Well, what's special about square? I don't know. We can come up with other things later. I don't know. They just have to have the same one. Sure. What gets to be difficult here with square is that there's a set length method and there's a set width method. So if I go make a square, we'll say, hey, I want a square. Square, small square equals a new square. And we'll say, hey, you're 10 by 10. But now I can say small square dot set length or set width and change it. Am I still a square? No, we've done a bad thing. So what we need to do now, we need to override my parent class's behavior to protect the integrity of my class square. So square should go and override these things. We should say, hey, I want to not get area, override public int void set length, given an int for length. So when you call set length, what I want to do that's special is I want to say super.set length, given the length, and super.set width, given the length. We'll just change them both. You want to set my length? Go for it. I'll just change length and width in rectangle. Now I'm still a square, right? And then we'll also do this for set width, given a width. We'll say, okay, you want to change my width? Sure, I'll just change length and width. I'm still a square now. So we can use that superclass's method to make sure that we maintain our integrity, right? The class's job is to protect itself, make sure it stays valid. It's not a square if it's 20 by 10. So all we have to do is say, okay, when you want to set length, just set them both. Right? Hey, rectangle, set them both, please. And we're good to go. Right? So this is what makes square special, right? It makes sure that it stays in square form. We can override. Not very interesting other than that, but sure. We can add other stuff later if we want to do other fun stuff with squares. Lots of fun stuff with inheritance. All right, I got 8 o'clock on the clock. 8 o'clock on the clock. Sure. When we take 10, we'll come back. We'll talk about the lab and the next project, and we can get working on it. And then we'll come go home for break, not think about Java for a week, come back fresh, feeling recharged, right? And you'll be ready to keep on moving. Okay.
So do we not have to work on the project or the lab for the week that we're not?
So you'll have 2 weeks to work on the project, not including the winter break. So I'm gonna assign project 2, but it won't be due until 3/14. So you'll have 3 weeks to do it instead of 2 weeks. So I'm assuming this week just doesn't happen. So the lab will also be due on 3/7. I'm trying. So all right. There's a lot of stuff. It's a lot. Yeah. Let me put some music on. We'll take a break. We'll see it once. You'll read it. We'll do it again. Do it a bunch of times. All right.
Okay.
All right. I forgot. I got one other thing I want to cover. This one is new and it's not in the textbook here. So we'll spend a little bit of time looking at this
Cool.
because it's the right way to make sure our code does what it's supposed to do. So while it's nice and fun to put stuff in main and to look at output, people are really bad at that sort of thing. So like when I said for our bottle test and we made a bottle and I drank from it, I had to keep in my head, okay, I put 150 in, I drank 50, and then if I drink too much, it doesn't work. And it's a lot of details to keep in your head. And that's rough. And then if you've ever written an English paper, you know how hard it is to spot anytime you have a word twice because you know what it's supposed to say, and when you go look at it, you just don't even see that it's wrong. So people are bad at that sort of thing. So what we're going to do is we're going to write code that tests our code because we want to make sure our code works. So we can make the computer do the checking for us and say, hey, computer, did you get this result? Yes or no? And the computer can check it for us, which is awesome. So it's called unit testing. So we're going to do that for a rectangle because that's probably the easy one right now. And then we'll look at some other interesting examples. So I know if I give rectangle a length and a width, what the area and perimeter should be, right? But what I don't want to have to do is go make a rectangle here and then call get length or call get area, look at the output and think to myself, does it match what I expect? That's a big pain, right? And it's failable here because I might do it wrong. I might look at the number wrong or that sort of thing. So to write unit tests, we're going to leverage inheritance. That's why we have to talk about inheritance first, which is really cool. So I'm going to come to rectangle, and I'm going to go to test. So this is a new thing here. So we're going to make a test class that will test our rectangle class. The word class comes out a bunch, but that's okay. So go to test, and it says, oh, I didn't find any tests. Do you want to make a new one? Yes, please. It says make a new test. And it says, hey, do you want to do this? Sure. Yep, that's fine. It says, what's the class name? So it takes the name of the class and adds the word test to it. So if you're testing rectangle, you get rectangle test. If you're testing dog, you get dog test. If you're testing mammal, you get mammal test. Fantastic. Those are all good. There's a bunch of really cool things you can do. We're not going to do any of those really cool things. So don't worry about any of these other checkboxes here. What we want here now are what test methods do we want? I want to test get area and I want to test get perimeter. So I'm going to check those two boxes. Those are the interesting ones that I want to test. Sets and gets are great, but I'll show you the shortcut for those later. So check those two boxes because I want to test those two methods and say, okay. It gets a new file for me here. It says, oh, okay. Imports this from JUnit, Jupyter, API assertions, all sorts of fun stuff here. Now, it's read it first. The first time you add your tests, Java doesn't know what this JUnit thing is because it's not actually part of the core Java library. All the other things we've done so far with Java come from the Java library. This is not the Java library. This is other code that's just widely used in the industry. JUnit's a fantastic testing library. It's not written by Oracle. So that's okay. So we need to go click the light bulb and say, hey, I want to add JUnit. Now don't pick 4. 4 is the older version. You want the version 5. 5.8.1 is the latest version. We'll say, hey, go and add that to the class path. Say okay. Right? It's a lot of fancy things happen behind the scenes. Maven is a tool that will go out and find code online and download it for you. So you can say, hey, I want to use someone else's code. Here's a library someone else wrote. If it didn't come with Java, we have to go get it from somewhere, right? We don't have this installed yet. So I'll say, okay, let's go get it. Go ahead and download it, add it, and then all the red should go away. Because now it's went and added it. So it actually does some other cool things here. Now it's in your external libraries section. It does all this stuff automatically for us. But now external libraries says, hey, when you want to run this program, you need to go and download this if it's not already downloaded. It's really cool. That's what the Maven tool does for us. It's a really handy tool. It's a pain to do this by hand. We don't have to. So it's nice. So external code that doesn't come with Java is managed. These are dependency managers. You depend on this code, this other library. It will manage that dependency for you. It's really cool. Eventually, when you get into JavaScript programming and you use JavaScript libraries, you'll see like libraries depend on libraries, depend on libraries, depend on libraries. You download one library and it's like you downloaded 1,000 all of a sudden. JavaScript is nuts, but that's okay. That's why we have dependency managers to do all that work for me. I don't want to go download 1,000 things myself. Any question? It's just another programming language. Yeah, it's very similar. Not the same though. I don't know why they both use the word Java, but we decided not to change it years and years and years ago. We've been stuck ever since. So it's hard to change names, but that's okay. It's just for web programming. So add it to your external library, you're good to go. Now this will work for you. So get area. What we're going to do when we write tests is we're going to write code, which is fun. So we're going to make code to check this stuff for us. So a convention, not a rule, not just a way things are done, is called the AAA format. So we're going to arrange, we're going to act, we're going to assert. So arrange means we're going to set up the variables we need to test. Act is we're going to call the code for testing and get values. And then assert, did we get what we expected? Okay. So to set up the variables we need to test, if I want to test get area, I need a length and I need a width and I need to know what the expected area should be. So if I make a 10 by 20 rectangle, my area should be 200, right? 10 times 20 is 200. So I'll say int length is 10, int width is 20, int. Now I like the word expected because this is, I'm saying I expect this value back out. Some people think it's a lot of typing, but that's okay. I don't, I type fast enough, so I don't care. If you don't want to use the word expected, it's okay. I'm not going to fault you for it. But it's nice, and then you'll see it here in a second. So these are the values that I need for my testing. Then I also need a rectangle, right, to test with. So I'm going to make a rectangle, rectangle equals a new rectangle, rectangle given length and width. Oops, that was the wrong key. Length and width. Okay, cool. So now we have a rectangle. So this is all the code we need. We've set it up. We're ready to test. So we've arranged everything. We're ready to go. Now when we act, what code are we testing? Well, we're testing the get area method. Does it actually give me the correct area back? So I'll say I have an int for actual area is rectangle.getArea. So this is the actual result. We get the value back from my class. So we'll call the method getArea and save it somewhere as actual area. So this is what the rectangle class thinks its area is given a length and width of 10 and 20. Right? Then we assert. Do they match? So this is assert equals. We say these two values should equal, and you give it the expected value and the actual value. So say, I expect this value back out. This is what I actually got. Java, please look and see if they equal each other. Right? I don't have to look at the screen and say, did it spit out a 200? Because eventually I'm going to probably mess it up. Or maybe I got the wrong number, that sort of thing. Then we can run our test. So you come up here and you right click, and you can say run. Now what you get is this really cool test explorer. The test explorer is fantastic. Every test that you have will show up here, and you either get a green check mark that it passed or a red X that it failed. If it fails, a bad thing happens. So if I just say, hey, I expected 0 here for fun. I know this won't work, but I want to show you that it will fail. I'll run my tests again here. And now we get a big red X. It's actually orange, but kind of reddish. It says, hey, it expected a 0. You actually got a 200. Something went wrong with your test here. What's going on? Well, because we told it 0. It shouldn't be 0, right? That's okay. So you can run your tests this way. Let me undo that. There we go. I expected area. And now my test should run. And it's even telling me, hey, this test is failing. You get all sorts of cool feedback in the UI. And in the rectangle class, I think it even tells us, where's my get area? Oh, okay, it's not showing. Sometimes it shows that it's failing in the class itself too, but that's all right. So this is testing get area. So the general rule of thumb that I like to tell people, and again, it's going to depend on where you actually go and work. Any code worth writing is worth testing. Why would someone pay you to write code if they don't want it to actually do what it's supposed to do? Right? So you want to test your code. Testing it in a main method sort of works, but it's failable. Testing it with a unit test means the computer is going to check it. So we have a higher confidence that our code will do what it's supposed to do. And then the cool thing is this code lives with the rest of our code so that we can run this test as often as we want. So typically what happens in an organization is you write some code, and it's very expensive to pay someone to write code because there's only so many programmers, only so many people know how to program, that sort of thing. The supply and demand. Go take an economics class. It's fascinating. The company is going to want to keep that code around for a long time because the longer they're able to use it, the more benefit they're getting for that cost, right? You've paid someone for 40 hours to write some code. If you only use it for a week, you probably didn't get a lot of value out of it. If you use it for a year, great. If you use it for 5 years, even better. You're continuing to get value out of the code that you put a cost into. This is why these state unemployment systems typically still run COBOL code. When I was in school, everyone said COBOL is a dying language. Don't take it, don't learn it, it's not worth your time, it's a dying language. That was 15 years ago. State unemployment systems are still running COBOL code because it's really expensive to replace working software. And you don't get any new benefit out of software that still does the exact same thing the old software does. So our state agencies, who only have so much money, say, oh, we'll put it off, we'll put it off, we'll put it off. Or if you're, is it Southwest Airlines? You say, oh, we'll update our system later, we'll update our system later, we'll update our system later. And then you have a bunch of cancellations, everything crashes on you. That sucks. But it's expensive to write new code. So unit tests will live forever with our code. And if the code exists for a long time, there's a high chance that they might just want to tweak something and just change a little behavior and say, okay, it used to do this, but could it also do this thing? Or maybe I need to do something slightly different. Or hey, the tax rate changed. We have to go and change how we calculate taxes because our federal income taxes change all the time, right? Sure, we can go in and change our software. So when we have the unit test, it can run every time we change our code to see, does it do what it's supposed to do still? Or if I changed something and the unit test stops working, I know I broke something, right? This idea that I can run all these tests to make sure that behavior that I expect to have happen still happens. So it's really cool. You can go out and look at like Microsoft's GitHub account. And let's go look for, we want code, VS Code here. Yeah, here's a VS Code repository. So Visual Studio Code, which is not Visual Studio, it's a separate tool, but that's okay, has this public repository and has all sorts of tests that run anytime the code changes. So you can say this is, see it's orange right now, some checks haven't completed. There's tests that are still running. If you have code to test your software, you can hook it into source control tools to say, hey, when the code changes in source control, please run the tests and tell me if it works or not. So as an individual developer on a team, I don't have to run thousands and thousands and thousands of tests. I write some code, I test my stuff, and I commit my change to GitHub or whatever my source control tool is, and this tool will trigger all of the tests to run to make sure you didn't change something that someone else depended on, right? It's really cool. So this idea, it's continuous integration testing. As code gets integrated into your source control tool, we run the tests on it. If you have that in place, then you have a higher degree of confidence that your software will work when you change it. You can then move to the next level, which is continuous deployment. There's this idea of continuous integration, continuous deployment pipelines. And depending on what your application is, you can update your program as soon as the tests pass. So the website like github.com or Khan Academy, when a developer changes the code, checks it in, all the tests pass, it will automatically go and update the production website. So I've got friends who work at Khan Academy now. So they make a change, and within a couple minutes, probably, I don't know, 15, 20 minutes or so, it's live on the website. So it's really quick for developers to make changes and see them working in production. And it kind of depends on your industry and what you're doing. Sometimes that's risky. You don't typically do that with healthcare software, right? Because if it doesn't work, bad stuff happens. So like healthcare software has a higher level of testing and they get humans involved and all sorts of fun stuff here. But again, depending on what you're working on, if you have automatic tests running, then you can have a degree of confidence that, yes, I can go deploy my code to production. People can go and use it now. So shortening the timeline from how long it takes to change something to when you see if it works and have people actually use it makes it easier to make changes. So you can be faster, more agile, and generally that means you can make more money. Right? It's all about money. Let's be honest, because your companies want to make money. So if it takes you a week to get code that was changed and then have someone do manual testing on it, and then they have to deploy it to a test system and they have to get someone to sign off on it, you probably know it's going to work and you aren't going to break anything and screw up someone's electronic medical record. That's a good thing, but it takes more time to make those changes. It's a little slower. So it just depends on your industry. But if we write code to test our code, we can run it automatically and you can hook it into your systems. It's fantastic. So that's the gold standard. Continuous integration, continuous deployment for software. It's awesome. So writing unit tests to make the computer do the checks for us is part of that. There's other levels of testing you can do. You can do integration tests and system tests. Go take the software engineering class with Mr. Hattie. He'll tell you all about it. It's fantastic here. But I want to show you unit tests. The idea is, does this unit of code work? And about the smallest unit of code we can test is a method. Right? So I'm going to test method by method. Does this method work? Does it do what it's supposed to do? Right? So did get area work? Did get perimeter work? So I'm just going to copy paste all of this because I'm a lazy person here. And I'm an efficient person here, I should say. So length, width, now I have an expected perimeter. We make a rectangle, we have an actual perimeter, meter, and we'll call get perimeter. So with a 10 by 20, 10 plus 20 doubled, right, should be 60. My perimeter should be 60. Now my actual perimeter, my expected perimeter. Did it give me 60? And I can run my tests. Cool. So again, I don't need to run it and look at the output to see if it gave me what it's supposed to do. I just have something here. So it's a very different way of thinking about code. Everything we've done before would like always go ask the user to enter a value here. And depending on what the user did, it'd be something more interesting. We could use that value. You can still do that sort of stuff. But for testing, if you know what the code is supposed to do, when you put A, B, and C in, you get X, Y, and Z out, we can write a test for it to make sure that we know what the code's supposed to do. Now, when the user starts interacting with it, great. We know it should work because we already tested it. Right? I don't have to write all this other code to do my testing stuff and then have something in main and ask the user to enter values and eyeball it. That's all fine if you want that, but it's not required. Right? I can write my unit tests. So we're going to use unit tests for the next project. So the other thing about unit tests, there's this idea of code coverage. It means how much code is running in my class when the unit tests run. So if I don't test get perimeter, there's no code coverage of this method. So, and there's tools you can buy that will measure this for you automatically. They'll run the test and they'll look at the code and say, hey, 75% of your code ran when this unit test ran. That's cool. Ideally, you get to 100%. Sometimes that's hard to do, right? So we haven't tested get length, we haven't tested get width, we haven't tested the sets really even, right? All we did was the constructor here. That's okay. We can go back and write more tests in a minute. Typically, I don't test any of the get methods like that have a, just get length, get width, set width separately. They're a big pain. I test them together. So if I'm going to test set width, I'm going to also test get width because I'm going to use get width to check the value that I just set. So I don't have a separate test for get and a separate test for set because you can't get the value out without using the get method. Does that make sense? So I'll just do those all in one. So we can write our own. You don't have to have it auto-generated. You just copy paste some here. We'll say, okay, this is my set width test. Sure. So we'll make a rectangle. So we can just use the default constructor, right? Oh, we don't have a default constructor. Oops. So that's fine. We'll make it 10 by 10. I don't know. We'll give it length and weight, length, right? So we'll give it 10 by 10. And then I'm going to call rectangle.setWidth, given width. So I need an expected width is 20. I guess I can just use width here. That's fine. We'll just use width. So we'll set the width and we'll get the actual width back out here from get width. And then my width should match the get width, actual width. Right? This is my expected value because I used set and I'm using get to get the value back out. Hey, rectangle, what's your value of width? This stuff should just work, and it's all auto-generated. It's not very interesting to test, but it gets you to that 100% code coverage. Gets and sets are really boring, but that's fine. They're pretty quick to write, and I can run it, and it should just work. The more interesting stuff to test is the things that you actually write, like get area and get perimeter that aren't auto-generated. Those are the interesting ones. So depending on your organization, they might have a standard like, hey, we want to get to 50% code coverage. We want to test most of what's happening here, but if you don't get to everything, that's okay. Like anything else, there's this idea of diminishing returns. You can spend lots and lots and lots of time testing every little thing here. You don't gain as much from getting from 90% to 95% to 100% as you did from getting the first half in. Let's get the big stuff in first. Let's test the important stuff. If the other stuff doesn't get tested, maybe you don't feel too bad about it. Now, I'll still always argue any code worth writing is worth testing. Right? Why would you pay me to write code if you don't think that it works? And how do I know if it works if I don't test it? So it's a whole funny story, but that's okay. Whoever signs your paycheck, they usually sort of set that policy, and you just smile and nod. It's like, great, I'll go along with it. It's okay, and it's okay. It's not the end of the world. All right, cool. So those are tests. So we need a lab and we need the next project. I didn't make any changes, did I? So let's do lab 6. This is lab 6. This is classes and inheritance. So 2 weeks from today, right, because we're pretending next week doesn't happen for break. At the end, we go set up a repository for you. Lab 6. Our Java template. All right. You know, I don't know. Okay, so let's do this. Let's forget lab 6. This is silly. Can I rename it? I don't think I can rename it. Shoot. Can I rename it? Edit assignment. Let's call this project 2. We'll do the project 1 here. We don't need a lab 6. So lab 6 is please use lab 5 as a starting point. Add unit tests for bottle, fill, and drink. So with bottle, fill, and drink, right? 2 different things could happen. You could get back a false, or you could get back a true, right? So when we're writing tests, I want to test both cases. I want to test where, yes, I tried to drink too much and it told me no, and I want to test, I tried to drink some and I said, yes, it could, and the current volume changes. Right? So you have to think about what changes in the code when you drink or when you fill. If you get back a false, nothing should change. The current volume should stay the same. Your expected volume should be exactly what it was before you call drink. When you call fill and it doesn't work, the current volume should stay the same. When you call fill and it does work, current volume should go up. When you call drink and it does work, current volume should go down. Right? So all the things that are changing, we want to test. So the tests get a little more interesting than just get area. Right? So we need to check, did we get a result back? So you can, in the assert things, you can assert true, some value, right? So you can have some sort of Boolean value, Boolean some result. Again, I don't have a method that gives me back a true or false, but I could put in here some result, right? So you could have your result is bottle.fill given some number of milliliters. It'll give you back a true or false, and you can assert is it true or is it false, right? You can assert true, you can assert false for those. So that's a quick one, and then you can also be testing. So you also then test the volume, right? What's the current volume? So you can do more than one assert at the same time. So you can have assert equals, right, the expected volume and the actual volume. Does that make sense? I didn't show that one, but we'll practice that. Yeah. So you go to your class, you right click on it, you say go to test. So if you have tests, it says here's your tests. If you don't, it says you want to make new tests? Sure, we'll make new tests. Okay. So we'll do both. So that's what we're going to practice for that. We're just going to write the tests for bottle, fill, and bottle drink. Don't worry about the sets and gets. Those are really boring to test. But fill and drink are interesting, and we wrote them. Right? So this is, we need test both cases for fill and drink, true and false results. Check that the current volume changed or didn't change as expected. All right. And we need this one as, let's turn on the website here. Submit the lab 5 URL again. Repository. So you just keep on using your lab 5 repository for this. For lab 6, we're just adding unit tests to our class here. So we don't even need the inheritance. This is just unit testing. So we're going to do unit testing for the project. Right? We won't do the inheritance stuff for the project because that's really a topic for next class.
So we use our lab 5 for lab.
So lab 5 was bottle, the bottle class. Now we're going to go add actual unit tests rather than put some code in main and see if it works for lab 6.
We're gonna play around
So
with bottle.
you probably had something in main, right, for bottle, like when we had bottle. We had lab 5 here, right? So we had a bunch of stuff here in main. Instead of using main to do the testing, we're going to make unit tests. So go to your bottle class and say, go to test, make some new tests. Yeah, we want to test fill, we want to test drink, right? And we want to test different kinds. So this is drink, we want drink, successful. And maybe then I'll also test drink fails, right? Drink unsuccessful. Right. Same with fill. Fill successful, fill unsuccessful. To get both of those different options, where one I get back a true and the volume changes, one I get back a false and the volume doesn't change. Nope.
What's in your main?
So I did this like if I got back a result here. So I had to eyeball this and say, I think I'll get this back out because I know 100 minus 50 is this. So there's a lot of mental load in checking this sort of thing here, testing in main. We're adding unit tests. So lab 5 was the bottle class. Lab 6 is writing tests for the bottle class from lab 5.
Yeah, so we just copy everything else.
So there's no new repository. Just keep using your lab 5 repository. Otherwise, you'd have to copy paste a bunch of stuff, and that's silly. Yeah, so just keep using your lab 5 repository.
Yeah, open up lab 5 and do
Yep.
it with lab 5.
Yep. So make sure when you do your import here, you want version 5, right? JUnit version 5, not version 4. Version 4 is bad stuff. Right?
What if you're attempting to do it and saying that you don't have a test subject?
I can take a look in a second. All right. Well, we do want to talk about the project then. So this is, I didn't put them in the lab category. That's fine. So project 2 is classes and unit testing. So this is, we said, due on the 14th. There we go, 14th. 6 p.m. because we need done by the time we're going to go over the solution. Right? Labs, you got a little extra time on. Labs are for your benefit. Right? Again, they're your pulse. Am I getting these things? Am I able to do them here? The projects are really worth the most points here. So this one is probably going to be worth 20 points because we are adding on. We don't get to get rid of anything here. Just keep on doing new stuff. All right. Yeah, let's forget the inheritance. That's okay. We don't need that. So we're going to write a class for what do I want? Electric vehicle. Electric vehicle. All right. So we're going to have attributes for food attributes for the kilowatt hours in the battery, and then the max kilowatt hours in battery. Right. This is the maximum you can charge it. Here's how your current charge is. Right. And then we'll have a kilometers per kilowatt hour is how far this vehicle will drive per kilowatt hour. Right? This is just a fixed number here. And then we'll have make, model, and color for fun. So, hey, this is a gray Chevy Bolt. This is a white Tesla Model Y. This is a blue Rivian. I actually know what their truck is called. Do they have a model for their truck? What?
Yeah,
R1T. Okay, yeah, so R1T, sure. So whatever make, model, and color is, sure. These are just strings here. We don't really care too much about them. But the interesting stuff is the kilowatt hours, max kilowatt hours, and your kilometers per kilowatt hour. Okay, so we're going to include get methods for all the attributes. We're going to include set methods for color. That's it. The only thing that changes in a car directly is the color. You can go paint your car any color you want, right? Once it's a Chevy Bolt, it's never not a Chevy Bolt. It doesn't make sense to change your make and model, right? Once it's the Tesla Model Y, it's always a Tesla Model Y. Now you can do like custom stuff to it, but it's still a Model Y, right? So those don't change. We're not changing the max kilowatt hours in battery. I know this technically does decline in the real world thanks to physics. Pretend it doesn't. It's okay. We're in coding land here, not in the real world. We're just going to pretend. Your kilometers per kilowatt hour will also change based on how you drive and weather and all sorts of other things. Just pretend it doesn't, right? We live in, it's always 70 degrees and sunny.
So what do you mean by make? Like, you can just put down the name.
I don't know why that keeps popping up. What do we need about what? Which one?
Next to kilometers per kilowatt hour. Make.
Make, model, and color. So make is the manufacturer, like Chevy or Chrysler or Stellantis. I guess that Stellantis isn't the make for a car though. A Ford, Tesla, right? Yep. All right. So set method for color, and then we're going to have a method for food method for drive.
So
Yeah.
are we setting the method for color, or we're not?
Yep, set method for color. There are no other set methods. So color is the only thing you set and can change anytime you want.
Got it.
Yep. So because you can paint your car, right? You can't change from a Chevy Bolt, right? We'll say the max kilowatt hours is always the max kilowatt hours. We'll pretend it doesn't degrade over time, and you'll eventually have to buy a new battery that costs as much as the car costs, and then it doesn't get recycled and it's bad for the environment anyway. But that's a whole other story. Let's not get into that. All right. So include a method for drive that accepts an argument for the kilometers to drive. Right. So when you call drive, you say, hey, I want to drive 10 kilometers. Right. A couple things will happen. So first, you need to see how much charge that's going to take. That's some arithmetic, right? So if I know how many kilometers to drive, and I know how many kilometers per kilowatt hour I get, I know how many kilowatt hours I need to have in the battery to make it that far, right? So if you get 10 kilometers per kilowatt hour and you want to drive 10 kilometers, you need 1 kilowatt hour. See if you have 1 kilowatt hour in the battery. If you do, great. Life is good, right? So if you can drive that far, reduce the kilowatt hours in battery appropriately, and return a true. Otherwise, return false. Tell them, nope, you can't do that. Too far. You better plan to go stop at a charger somewhere. Good luck road tripping. Right? We're going to do unit tests, yep, to make sure this stuff works. Yep.
Don't get stuck anywhere cold.
I'm sorry? Kilowatt. I did. Kilowatt hours in battery, right? Kilowatt hours? Okay. Yep. Thank you. Include a method. Include method for charge that accepts an argument. Oh my goodness, I can't spell. Argument. That's not helpful text. An argument. Yeah, I don't. Argument for the kilowatt hours to charge. Now, I don't know a lot about batteries, and usually charging systems are smart enough to stop charging. We're going to pretend we don't have any of that. So if you want to charge 100 kilowatt hours and it doesn't fit in your battery, just tell them no, because it'll probably explode otherwise, or do something bad, or light on fire and burn down your garage, and then they'll have to recall the car, and bad stuff will happen. Right? I'm sure that's not the real world. It's okay. It's okay. So if there is enough, is room to charge? Does that make sense? Charge. Increase the kilowatt hours in battery appropriately, and return true. Otherwise, return false. Right? Similar idea, just kind of like we did with bottle. Right? You're going to fill it. You're going to drink from it. Cool. We're just doing with a different example here. Yeah.
Wait, so by you saying if there's enough room to charge, does that mean like when you charge it, you're going to charge it a set amount?
So you have to tell it how many kilowatt hours you're going to charge. Say, hey, go charge 5 kilowatt hours.
But that's setting that, so you say 100 kilowatts and your battery has 20 kilowatts still in it, that will return false.
So if I want to charge 100, my max is 100, but I have 20, yeah, it doesn't fit. Just like bottle. You tried to fill it up, doesn't fit, just tell you no. Yep.
So it's like the amount you're putting in is, you determine that when it's set.
Yeah. Yep. All right. And then return false. And then we're going to include unit tests for 100% code coverage of charge and drive. Right? That means you have to cover both cases, the true and the false, just like we're doing for lab. So if you get the lab done, this should be really easy. Right? If you don't get the lab done and the lab doesn't make a lot of sense, this is going to be really hard. But that's why we're practicing. Right? And we got some time on this one. All right, so we need a rubric for project 2. Project 2. Complete or missing. 0 and 5. So this is the electric vehicle class. We're going to have a constructor that accepts values for the attributes. Right? If you don't have a set method, you have to take it in as in the constructor, because there's no other way to set the make and model, because there's no set method for it. But you have to have a constructor that takes those values because there is no other way to change them, right? So you need a way to set all those values, okay? And it should default the current kilowatt hours to 0. So don't take a value for current kilowatt hours. We'll pretend when this is brand new, it's empty. The battery has no charge. When you put you put the car together, there's no charge there. They probably don't ship batteries full of charge. I feel like that's a bad idea, but I don't know a lot about batteries, so we'll just pretend, right? We're gonna make it up. Okay, that's 5 points. And then our drive method accepts an argument. I don't know. Do you need all the details again in the rubric, or can I just say drive method?
Yeah.
Okay, drive method, charge method, and then we want drive tests and charge tests. So we got to do this with custom points rubric. Sorry. So we'll do 4 points for the constructor, 4 points for that, 4 points for this, 4 points. Oh, I can just do 4 points for everything. That adds up really fast. That's 20. One of these days I'll learn how to math. I'll score. All right. So 20 points. Right, 4 for the constructor, 4 for drive, 4 for charge, 4 for testing drive, 4 for testing charge. Okay. Again, do the lab first. Make sure the lab makes sense. And we can come back to this. Yeah.
There's no repository for lab 6.
Oh, I didn't add it. So yeah, so for lab 6, just use lab 5 because you're just adding tests to bottle.
And then just when we put it in there, like,
The lab 5 repository again. Yep. But I forgot to do it for this one though. That's right. So this project 2, submit the URL to your repository and a self-assessment using the rubric. So nothing has to be in main for this one, right? I just need the class and the tests.
Yeah, we're gonna.
All right, awesome. All right.
I know. I want to get this lab done.
I'm going to end the stream. If you guys got questions online, find me on Discord. If you wander around the room, folks, take care.